tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before.
This is a partnership between NASA and the Indian Space Research Organization.
NISAR is going to be one of the most sophisticated radar satellites that has ever flown in orbit.
NISAR is going to open our eyes to seeing the ground in places that otherwise has been obscured.
NISAR will help us to better understand earthquakes, volcanoes, landslides, floods, wildfires, oil spills.
The society will also benefit due to its contribution to disaster management and providing food and water security.
These are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds, and we all belong to the space community. That's it.
You are looking live at Mission Control at NASA's Jet Propulsion Laboratory in Southern California. The team here is waiting for the launch of NISAR, a powerful Earth-observing satellite built to track changes in our planet like never before. And in just an hour and 8 minutes, we are taking you to the Satish Dhawan Space Center in Sriharikota, India, to watch NISAR launch on a GSLV rocket. Hello and welcome. I'm Raquel Villanueva, live at NASA's Jet Propulsion Laboratory, and here with me today is Dr. Sue Owen. She is part of the NISAR team and also the Deputy Chief Scientist here at JPL. Thank you for joining us today, Sue.
Thanks for having me here, Raquel. I'm really excited to be here.
Yeah, and we have teams standing by here in Mission Control and in India because NISAR is a joint mission between NASA and the Indian Space Research Organization, also known as ISRO. So Sue, can you tell me a little bit more about that partnership?
Yes, Raquel. The NASA and ISRO partnership on NISAR is the first time that the two organizations have worked so closely on a mission, with both organizations providing major hardware contributions. And the name NISAR has the partnership right in it. It stands for NASA-ISRO Synthetic Aperture Radar, so it has the partnership and the type of measurement that NISAR will be making.
Well, I'm excited to have your expertise here today, and soon we will hand things over to our ISRO colleagues for their live coverage of the launch. With Sue here, we have a chance to answer your questions live. If you have a question, send it our way using the Ask NISAR hashtag, and we will try to answer as many as we can live. NISAR is an Earth-observing satellite set to be a game changer for how we study our planet's surface.
Yes, NISAR is going to be able to measure changes both big and small as a centimeter on the Earth's surface. It can measure surface movements caused by earthquakes, by volcanic activity and landslides. It can track changes in glaciers and the melting of ice sheets. NISAR will measure flooding caused by storms and hurricanes, and also observe how forests grow and shrink, and so much more.
You know, and Sue, let's take a moment to acknowledge just hours ago there was a major earthquake, 8.8 in magnitude in eastern Russia, and officials are still assessing injuries and damages.
Yes, and our thoughts are with the people who are impacted by this earthquake, and it's these types of events that remind us how important the types of measurements that NISAR will be making will be. They will help us to be able to forecast where these types of events occur, as well as assess the damage after these earthquakes and tsunamis.
Well, thank you so much for that update, Sue. So we will dive into the science behind NISAR a little later in the broadcast. Now let's take a look at how NISAR made its way onto the launch pad in India on a GSLV rocket.
So you can see here that NISAR is moving on to the launch pad, and this is just one of the final stages of its journey to the launch pad. NISAR has actually been traveling around the world as it's made its way here. It started both in India and in the US, with India building the SSAR and the US building the LSAR, and then the SSAR traveled to the US to be integrated, and then the integrated radar traveled back to India, and now it is making its final movements to the launch pad, getting ready to launch and travel up into space, where we'll be making the observations that will enable the science.
And as a reminder, this is a joint broadcast with ISRO, and they will cover launch, which is about an hour and 4 minutes away. And we now know what NISAR will study, but how does it actually all work? So to help break that down, we have Adrian Borsa from the NISAR science team. Adrian, thank you so much for joining us today.
Great to be here.
So for people new to this technology, how does radar allow us to see changes on Earth's surface?
Well, because NISAR is a radar mission, it is essentially operating all the time, all weather, day or night. It can even see through clouds, for instance. So what NISAR is actually observing is changes in vegetation and vegetation cover, as well as changes to the ground surface underneath. So those ground surface changes might be reflectivity changes from soil moisture, which is relevant to agriculture, or even surface motion from earthquakes, volcanoes, and subsidence, sort of giving us insight, scientific insight into the processes going on inside the Earth.
And measuring those changes, are there any specific regions here in the U.S. that this data could have a real impact?
Absolutely. So I mentioned earthquakes, which are prevalent on the West Coast. Thinking about volcanoes, they're active in Oregon, Washington State, Alaska. Wildfires are a key issue in the western U.S., and NISAR can observe the vegetation impacts from those. Let's say turning to the southeast, floodwaters from hurricanes, NISAR can track those, and we don't want to leave out the Midwest. With a lot of agriculture, NISAR is seeing land subsidence that's due to groundwater pumping and then recharge, which is really important for groundwater management. So pretty much everywhere you go, NISAR will make an impact.
So Adrian, can you tell us why it's so important to make those measurements globally and consistently, like NISAR will be making twice every 12 days?
Yes. In fact, tying back to this earthquake we just heard about yesterday in Kamchatka, that's a perfect example. So thinking about earthquakes and volcanic eruptions, they are massive, high impact, but relatively rare at any given location. So NISAR's got global coverage, continuously operating over all land surfaces. It is actually making these observations, like in Kamchatka, giving us the scientific insights that we can bring back to the U.S., for instance.
Thank you, Adrian. That's great.
Adrian, really appreciate your expertise. Thank you so much for joining us today. So as you heard, NISAR's data can support a lot of communities, especially farmers who can track their crops and how they're changing over time. Here's how.
NISAR is a satellite mission that is going to be observing the Earth with radar. It will actually have two radars that view the Earth at different wavelengths. We can combine those data that allow us to learn more about things like vegetation and soil moisture than we can do with only one of those wavelengths.
So NISAR is definitely going to be a breakthrough for field scale soil moisture, which is one of your main drivers of both food security and then as well more on the economic commodity forecasts.
NISAR is going to look at objects that's the size of about 60 meters in size, which is typical soccer field, to about 200 meters. We'll be able to see whether a particular patch of that size is wet or dry.
The current land surface models can't really quantify irrigation, so NISAR is going to now help understand how much water is actually being used to grow a crop, which will help us save water, so that's kind of a big deal.
Understanding the moisture in the soil can definitely help farmers better understand what's happening underneath the ground. Do they need to water? Is there too much water there? They just need to kind of let things grow. You know, are they in a drought condition? If they do need to irrigate, how much? All those different things just to, you know, better help those farmers make the best possible decisions for their crops.
I truly believe that agriculture is one of the kind of central components to many what we call sustainable development goals. Poverty, nutrition, livelihoods, environment, whether it's water, soil, air, to lift people out of poverty. So it's something I personally believe in philosophically and hope to spread the wealth.
And so how soon can farmers know about their crops?
So the science data from NISAR will start flowing around 90 days after launch. So that will be in the October-November timeframe, just in time for fall harvest, where we'll be getting apple crops and pumpkin crops.
And you were mentioning there is something else that NISAR can measure as well?
Yes, so it can also measure bridges and roads and infrastructure and the land subsidence that can impact those that type of infrastructure. So very important for how we live on this planet.
And we'll learn a little bit more about that soon enough. So we are just about 59 minutes away from launch, and back here at JPL, friends and family are starting to gather inside Von Karman Auditorium to watch liftoff. So Sue, who is here to watch launch today?
So we see everybody waving. We have friends and family of the team. Hi, everybody. It's really wonderful to see everybody here. We have engineers, we have technicians, mission operations specialists, and scientists. It's really taken a large community to get NISAR to the launch pad today. I just want to say thank you to everybody who supported NISAR over the years.
It's great to have them here. So from lush rainforest to dry grasslands, Earth's ecosystems are always changing, but some changes are harder to see from the ground. That's where NISAR comes in, and here to tell us more is Alexandra Christensen. Thank you for joining us, Alexandra.
Thank you for having me.
So how can NISAR help us understand what's happening to forests around the world?
Well, as you know, NISAR has 2 radar instruments on board. The L-band radar is particularly useful for penetrating forest canopies, bouncing off the tree trunks and the ground underneath. This can tell us about the forest structure, the amount of living woody material, and forest disturbance from deforestation and wildfires. We can also track burn severity and ecosystem recovery after a fire. The S-band radar, on the other hand, is more sensitive to the upper layers of the forest canopy, can detect forest thinning or loss of leaves, which could indicate tree stress. And by combining data from both of these bands, scientists can construct a more complete picture of our forest health.
That's so fascinating. So why is it important to see if forests are growing or shrinking?
Yeah, it's super important to see if they're growing or shrinking because forests play a huge role in our planet's health. So for example, forests are biodiversity hotspots, home to many plant and animal species. So forest loss means habitat destruction and wildlife endangerment. Forests also provide essential ecosystem services such as regulating our water cycles, preventing soil erosion, and supporting the livelihoods of our communities. NISAR will scan the Earth nearly 2 times every 12 days, and by regularly imaging the same area over time, we can detect small, gradual changes in forests. So NISAR doesn't just measure trees, it also measures trends.
And speaking of ecosystems, can NISAR help us see how ecosystems respond to things like droughts and floods?
Yeah, absolutely. NISAR's radar technology is very effective at observing water, both on the surface and in the soil. And water is a foundation of ecosystems. So during droughts, NISAR is sensitive to water content, so it can see if plants and soils are drying out. Scientists can map moisture stress, which could indicate vegetation decline, increased fire risk, or that groundwater supplies are shrinking. During floods, we can see the extent of flooded areas, even through clouds. Water has a very different radar signature than dry land. So NISAR can see how much land is covered by water and how it's spread. So by comparing...
Thank you so much, and Alexandra, that was really great information. I appreciate that so much. So NISAR is also sparking curiosity in people of all ages. As part of the NISAR Art Challenge, students were encouraged to imagine Earth the way NASA sees it from space. So Sue, let's take a look at some of those submissions.
Oh, these are really wonderful, Raquel. I love seeing how the kids have imagined how the Earth changes and how we're going to be seeing it with NISAR. We see volcanic eruptions, we see changes in vegetation, we see changes caused by the changing seasons, as well as by natural disasters like volcanic eruptions, by storms, and so many other things. I also love seeing the different ways that the students have used to depict this. Yes, we've got crayons, paint, collages. It's really wonderful.
And it's really great artistic work as well.
Yes, and soon we'll have NISAR radar to add to our imagery of Earth's changes.
Fantastic. So to see all the artwork, scan the QR code you see on your screen. So as a reminder, we are about 54 minutes from launch, and soon we'll take you to India for live coverage. So Sue, let's get to some of those social media questions coming in.
Great.
So first off, we have Science of Everything on X who wants to know, hey NASA, I want to know how you guys got the name NISAR. You explained it earlier, so let's hear it again.
Oh, sure. So the name NISAR stands for NASA ISRO Synthetic Aperture Radar. And so you can imagine, as a NASA-ISRO partnership, taking synthetic aperture radar measurements, that's how we got the name.
And Manish on YouTube asks, given that NISAR will generate more daily data than any prior Earth-observing satellite from NASA or ISRO, how is NASA preparing to handle process, volume, and distribution of such massive data volumes?
Oh, that's a great question. So NASA, in collaboration with ISRO, but NASA has been working for a long time to prepare for the tsunami of data that we're going to be getting from NISAR. And so one of the key ways that we're going to be doing that is by storing the data and analyzing the data on the cloud.
And we have Suprasha on YouTube wants to know, how will NISAR be helpful for humankind?
How much time do you have? So NISAR will be helpful for humankind by providing data and information that allows us to see what's happening from natural disasters. We've talked about the impacts of natural disasters. It will also help us see the small changes that are difficult to detect with the human eye that can impact the infrastructure on the ground, as well as measuring changes in soil moisture and changes in vegetation that help us understand how we grow food that we need to live. So lots of ways. Those are just a few.
I love the list that you created, so thank you so much, Sue. And keep those questions coming using the hashtag AskNISAR. So NISAR will track small shifts in Earth's surface, detecting early signs of volcanic eruptions. Let's take a look.
One of the real key questions in our field of volcanology is to try to understand when is a volcano getting ready to erupt and when is something that we observe happening there just a natural process that isn't going to lead to eruption.
Deformation is often one of the first signs that a volcano is becoming restless, and then we also look for increased seismic activity. But the earlier that we can detect that deformation, the more we can refine what kind of a forecast we have and whether or not we need to be concerned about eruptions.
NISAR has a couple of capabilities that are going to be really transformative for volcanology. The first is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space, and that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency, and we're going to get the ability to see through a lot of this obscuring vegetation, and that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they can have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.
And Sue, there are other natural hazards that NISAR can monitor as well.
Yes, and just recently, in the last few hours, there was a major earthquake in Russia, magnitude 8.8, and NISAR will be very important for being able to forecast as well as assess the damage caused by those types of earthquakes and the tsunamis that they can generate as well.
Well, thank you for breaking that down for us, Sue. And NISAR's journey to the launch pad was a global effort. JPL built the L-band radar while ISRO built the S-band. The two were integrated at JPL into a single radar payload. That system, along with the boom and reflector, was then shipped 9,000 miles to India. In Bengaluru, teams from both agencies worked together to assemble and test the satellite. After final checks, it was transported to the Satish Dhawan Space Center in Sriharikota, India, for final launch preparations. This partnership brought teams together from around the world, including JPL systems engineer Akshara Krishnamurthy. She grew up in Bengaluru and has been traveling from California back home to India to support the mission. Let's take a look at part of her journey.
Hey everyone, I am at LAX right now. I just finished security and I'm ready to board. It's the first of 3 flights with stopover in Dallas, Soha, and Bangalore. I have arrived in Bangalore Airport, or as we call it, Bengaluru, after about 31 hours of flying. I'm excited, but I'm also super tired, so I'm going to go get my bags and head to the hotel, and I'll see you later. This is where I grew up in Bangalore. It is amazing and nostalgic, in fact, to come here because it was my dream job to work at NASA. Now I'm able to contribute to my home country on a project where we're doing an international collaboration. So super excited to be a part of this effort and also grateful for this experience. So finally, I'm here at the URL Satellite Center, URC, here in Bangalore. This is the ISRO Center where we're going to be working the next few days. We're gearing up for our next set of system level testing. Today we're going to have a day full of intense technical discussions with the NISAR team here at ISRO right behind me. I'm walking in to Rajsthani. It's a traditional Rajasthani cuisine restaurant. You will get to see one of India's cuisines. It has 28 states, and each state has its own cuisine. And here we explore different types of cuisines with our ISRO colleagues and friends. We're waiting for the traditional lamp lighting ceremony, what we call the diyas. And the background music that plays is really world peace and happiness prayer. It was so soothing and it was such a positive energy here. I wish you could all witness this. Thank you for joining me on this tour of my city. I hope you enjoyed it as much as I did. I can't wait to see the launch and operate this amazing observatory.
Sue, you also traveled to India for this mission.
Yes, I did. It was really an amazing experience. It was my first trip to India. I went in February of 2020 to meet with the science team in India, and again a few years later.
You know, speaking of travel, NASA leadership is on the ground right now in India getting ready for launch. Here's what they had to say.
I'm here in India, super excited as we are here to support our NISAR mission as it takes to the skies. And today, it's all about NISAR.
It's an exciting week for NASA. We have our Crew 11 launch in Florida, and we have our NISAR launch here in India, which is where I am with our NASA teams. Super excited to be here, an incredible collaboration between India, the United States. This launch really represents the culmination of over 10 years of collaborations between our two countries. So go NASA, go JPL, go ISRO, go NISAR.
I'm here today at IIT Madras for the pre-launch science team meeting for the NISAR mission. We are learning all about the terrific science that's going to come out of this mission. I just heard about how NISAR will revolutionize our understanding of how earthquakes happen around the globe. The excitement for launch here is palpable, and I can't wait to get back inside and hear more.
Go NISAR indeed, and to help us better understand the spacecraft, you have brought a model with us.
Yes, so here we have a model of the NISAR spacecraft. You can see here we have solar panels to power the spacecraft. Here we have in this octagonal structure, this is the radar instrument structure, or the RIS. So the L and the S-band radar are housed here. And then behind that is the spacecraft bus, which houses the power and the telemetry and other key functions of the satellite. Then attached to that is this impressive boom that holds up the nearly 40-foot in diameter gold reflector antenna reflector of NISAR.
And so it is not going to launch in this configuration, right? It has to be packed up. So how does that work?
So right now it's all folded up and stored and ready for launch. And so the way that it folds up is this boom actually wraps around the radar instrument structure. But first, the antenna reflector folds up. So it kind of collapses like an umbrella or a camp chair, and then it's stored underneath the radar instrument structure in this configuration, and it's held in place by this little latch down here.
Well, that is exciting stuff. Thank you so much for the breakdown, Sue. So NISAR is a joint mission between NASA and ISRO, but that is just one example of how our two countries are working together in space. So here's more in your Artemis Moon Minute. NASA's Artemis campaign uses missions on and around the moon to prepare for future human missions to Mars and highlights a new era of international cooperation championed through the Artemis Accords. Established in 2020 by the United States, led by NASA with the U.S. State Department and 7 other initial signatory countries, the Artemis Accords outline a practical set of principles such as peaceful purposes and transparency to guide space exploration cooperation. India became the 27th country to sign the Artemis Accords in Washington, D.C. in June 2023. Later that year, NASA and the Indian Space Research Organization, or ISRO, cooperated on a first-of-its-kind lunar experiment. They transmitted a laser beam from an orbiting NASA spacecraft to a small reflector device on ISRO's Vikram lander on the moon. This method of precisely locating targets on the moon could help guide Artemis astronauts to the surface in the dark or mark the locations of spacecraft already on the lunar surface, so astronauts or uncrewed spacecraft can land near them. As of today, over 50 nations have signed on to the Artemis Accords. And that's a look at your Artemis Moon Minute. The Artemis mission, scan your QR code you see on your screen. And as you do that, it's also worth mentioning another NASA and ISRO partnership. Last month, ISRO made history with its first astronaut visiting the International Space Station as part of the NASA and Axiom Space's AX-4 mission. Shifting gears back to NISAR, the Earth-observing satellite is set to give scientists a clearer view of how ice is moving, melting, and reshaping our world. Here to tell us more is Eric Vigneault. Thanks for being here today.
You're welcome.
So how can NISAR help us understand how tracking melting ice from glaciers and ice sheets is important?
NISAR will track the motion of glaciers and ice sheets, and combined with information from climate models and thickness of the ice, we can figure out how much they contribute to sea level rise. And glacier melt is one of the main contributions to sea level rise. We need this information to inform society on how to protect ourselves from sea level rise. And then the scientists will be able to use this information in climate models to project what sea level would look like in the next few years, in the next decades, in the next century, so we can better protect society and save human lives too.
Very important information.
So Eric, can you tell us how will NISAR help us see changes in the ice that are difficult to detect from the ground?
Yeah, so the NISAR will cover the globe in 12 days, and in particular it will cover all of Antarctica for the first time. And conducting these measurements in the Antarctic would be nearly impossible for ground parties because the continent is so vast. It's larger than the United States. And it would put these field teams in great danger if they had to do this work continuously on the Antarctic. So with NISAR, we'll have this information continuously about what's happening in the Antarctic. If there's any important event, we'll see it, we'll catch it, and it will be part of public knowledge from this data.
Thank you, Eric. That's great.
Eric, that was really important information. Thank you so much for joining us today. And let's take another look into mission control here at JPL, where the team is excited to watch launch. And just a few days ago, I had a chance to speak with Dave Gallagher, the new director of JPL, to hear his thoughts on launch. Dave, thank you so much for joining us today.
It's my pleasure, Raquel. I'm happy to be here.
From your perspective, why is NISAR such a groundbreaking collaboration between NASA and ISRO?
This is the single biggest collaboration in space between the United States and India. It's enormously important to both countries, and space diplomacy is key right now. One of the most challenging things about this collaboration is the difficult time zone. So we have our JPL engineers and scientists working shoulder to shoulder with their ISRO counterparts, and the team is just working fantastic together.
When people think of JPL, they probably think of Mars rovers or deep space exploration, but JPL is also dedicated to studying Earth science and our home planet. What do you hope NISAR will achieve that adds on to those many Earth missions?
Well, Raquel, just to build on what you said, we actually have 4 decades of pioneering missions to really understand our home planet, missions like GRACE, missions like EMIT, like SWAT, that are born here and really have turned out to be some of the most important missions in existence to understand our home planet. NISAR is going to give us an unprecedented view of the Earth, both our ice mass, land mass, and because it's synthetic aperture radar, which is a technology really pioneered at JPL, it can work day and night and through any kind of weather.
Can you tell us how the JPL team contributed to NISAR and what that says about JPL's history of working on international partnerships?
Absolutely. This will be the first mission to use 2 kinds of radar. The L-band radar is developed by JPL, the S-band radar is developed by ISRO, and that combination of those 2 radar systems will allow us an unprecedented understanding and view of the Earth. NISAR builds on JPL's long-standing legacy of working with international partners. We can drive innovation when we take advantage of each country's strengths. We are actually stronger when we work together than doing this alone.
So looking ahead, what kind of legacy do you hope NISAR leaves behind for future Earth science missions?
What I'm most excited about with NISAR is the real-world applications, things like infrastructure monitoring, natural disaster recovery and response, agriculture management. This is going to make a real difference for real people around the world.
Thank you so much for your time and insights today.
Thanks.
As a reminder, this is a joint broadcast, and we will hand it over to ISRO, who will cover NISAR's launch, which is just about 36 minutes away. And Sue, we have another social media question coming in. So Pradeep on X wants to know, how will NISAR's satellite be different from others, and what capabilities does it have which others don't?
That's a great question. So a key difference from NISAR is that it is going to be globally measuring at very high spatial resolution. So this is the technology or the capability enabled by the radar technology that is called SweepSAR, as well as the very large antenna reflector that we saw earlier. Another key innovation from NISAR is the dual band radar. It will be the first satellite to be measuring with both L and S band.
Well, thank you so much for those questions. And if you have a question, send them over using the hashtag AskNISAR. And as we showed you about 15 minutes ago, NASA leadership is on the ground right now in India. That includes Associate Administrator for Science, Nikki Fox. I was able to catch up with her before she left to talk about this historic partnership. Nikki, thank you so much for joining us today.
Oh, you're so welcome. It's a great day.
NASA has more than 24 missions focused on Earth science right now. what makes NISAR unique?
We really don't quite understand why our planet is always moving. So the surface of the planet is always kind of moving, and we can't detect it. But with this amazing technology that NISAR brings, we're going to be able to actually start studying these tiny little, almost landslides, these little tiny quakes. And the goal, of course, being that we find a signature that happens before a major disaster that would allow us to then look for that and search for it and almost be able to predict these big disasters before they happen.
And you mentioned those tiny changes that this mission will track. What kind of other insights may we gain that could help people in their everyday lives?
We're also getting the data into the hands of people that need it, the decision makers, the people who are working with the first responders to actually go in and help people once these disasters have happened. You mentioned how many missions we have in the Earth Science Fleet. And when you put all these missions together, you just get so much more out of them. And so having NISAR launch take its place in the Earth Science Fleet, really illuminating so much more about our home planet, NISAR is just going to give us unprecedented views to add to the information we have about our planet.
And Nikki, we are so close to launch. So what are you looking most forward to right now?
Oh my goodness, I love a good launch. I'm not gonna lie, I'm a launch junkie. I love everything about them, but really it's that final sort of, when you get to that final countdown and you just appreciate, for me, being with the team, being with this combined team who've worked so hard to make this happen. I know I've been on mission teams and it's almost like you're sprinting to the start line as a scientist. You've done all the work, the mission is there, it's on the rocket. Once it launches, all of the science begins.
Fantastic. Thank you so much for joining us today.
Thank you so much. Go NISAR.
And Sue, we have more social questions coming in, so why don't you answer some more? We have Ayush on YouTube who wants to know, how long will it take to get NISAR fully running?
So that's a good question. So it will take about 90 days before we start collecting, before the science mission starts and we start collecting science data. So in those 90 days, we will be deploying the satellite, deploying the boom and the reflector, as well as testing out all of the radar instruments and making sure that everything is calibrated and validated initially correctly.
So 90 days from now will be like Christmas for you.
Yes, it will.
And Rian on YouTube wants to know, how will ISRO and NASA ensure NISAR's data is accessible and useful for developing nations most affected by climate change?
Oh, that is a wonderful question. So NASA has an open science policy and open data policy. And so all of the data that NISAR will be collecting, all of that L-band data will be available through a NASA archive at the Alaska Satellite Facility, and then India will also be making their data available, the S-band data and L-band data that they will be processing, available and openly free and available to everyone through their data archive as well. So all of the data will be free.
Great, and we have a couple more coming in. Raul on X wants to know, why is NISAR's antenna so big compared to other Earth-observing satellites, and what is it made out of?
So I can answer the first question. I don't think I have the exact facts for the second question about what it's made of. But the reason why it needs to be so large is that area gives us the very high spatial resolution that is going to be unique to NISAR, combining that global coverage as well as the high spatial resolution. So we need that surface area to collect all the reflected radar signal from the Earth, focus it onto the receiving antenna, and that will give us the high spatial resolution.
Thank you, Sue. So Anjin018 on YouTube wants to know, since NISAR uses both L-band and S-band SAR, How does the dual band radar improve surface imagery accuracy, especially in densely vegetated and urban regions? These are some great questions.
Yeah, so how will the L and S band radar help us improve the, what was it, the surface deformation?
Vegetated and urban regions.
Vegetated and urban regions. So that because the two different radars are different wavelengths, they will be sensitive to different parts of the vegetated environment. And so we'll be able to characterize the vegetated areas more accurately using the two different wavelengths.
Really appreciate your expertise, Sue. Thank you so much, and thank you all for your questions. So, Sue, launch is just 30 minutes away, so tell us how much this moment means to you and the NISAR team.
You know, this is so special. I've been working on NISAR, been part of the team for over 10 years. I know people have been working on this mission concept for decades. And so it's really an amazing moment to finally be here at launch. And we're just so excited to be starting the science observations, to start collecting the data. It will be so impactful for so many people on the planet.
Great, Sue. So we will now take you to the Satish Dhawan Space Center in India for coverage of liftoff in about 30 minutes from now. Remember, NISAR is a joint mission between NASA and the Indian Space Research Organization, or ISRO. Part of ISRO's coverage will be in Hindi, but we will be having an interpreter providing English translations so you can follow along. And we will see you again after liftoff.
Mission intends to place the NISAR satellite weighing about 2,400 kilograms in 747.4 kilometers circular polar sun-synchronous orbit with an inclination of 98.4 degrees.
Namaskar, Shubh Sandhya.
Good morning, good evening. There is a historical day in this
NASA
experienced agencies NASA and ISRO.
जिसे हम NISAR, NASA, ISRO,
We say NASA, ISRO, synthetic aperture radar. We know
के साथ एक स्वर्ण अध्याय लिखा जाएगा जो कि अंतर्राष्ट्रीय सहयोग.
we will be writing a new history in the international space.
मैं विकास स्वर्णकार आप सभी का.
So my name is Vikas Swarnakar. I welcome everybody in this lunch. I will be Madhuri will be here. She will be commenting in English. So we are at the Sriharikota Satish Dhawan Space Center.
ISSLive NISAR mission के
ISSLive NISAR 30 July 2025 Indian time 5:40 p.m. 25 GSLV S16
किया जाएगा. इस प्रमोशन मिशन का उद्देश्य है
in this
किलोग्राम वाले भूप्रेक्षण उपग्रह नाइसार को 747 किलोमीटर की गोलाकार
747 kilometer
इस प्रमोशन मिशन को पूरा करने के लिए
in this mission to complete GSLV the space vehicle is used.
इससे पहले यह 17 उड़ान.
Before this it has done 17 launches.
साल ही हमने 29 जनवरी 2025
this year 29 January 2025 GSLV F-15 NVS-2
सफलतापूर्वक प्रक्षेपण देखा.
So we have successful launch has been done already.
मिशन जिसका नाम है.
So next mission will be GSLV S16 NISAR mission.
NISAR is the world's most sophisticated Earth observation satellite, jointly developed by ISRO and NASA. Its 12-meter deployable mesh antenna is one of the largest in Earth observation history and uses a unique operating mode called Sweep SAR to observe Earth with a swath of 242 kilometers and a high spatial resolution. NISAR will carry L-band and S-band radars, which are designed to work independently or together, while the L-band radar contributed by NASA will work with longer wavelengths of about 25 centimeters to penetrate vegetation, soil, ice, detailed tracking of soil moisture, forest biomass, ice sheet thickness, and subsurface features. The S-band radar contributed by ISRO will operate on shorter wavelength of 12 centimeters which makes it highly sensitive to surface characteristics. It is useful for detecting crop structures, snow cover, and fine surface deformation.
नाइसार नासा इसरो सिंथेटिक अपर्चर रडार
NISAR NASA is
संयुक्त रूप से विकसित
this is combined mission.
वेधशाला है। इसकी खास बात यह है कि नाइसार
specialty of this is
तैयार कर पाएगा और पृथ्वी के पारिस्थितिक तंत्र, बर्फ का द्रव्यमान, वनस्पति बायोमास, समुद्र के स्तर की में वृद्धि, भूकंप,
penetrate vegetation, soil,
प्राकृतिक खतरों,
landslide,
डेटा प्रदान करेगा।
it will provide the good data.
अब आप सभी दर्शकों के सामने GSLV
S16 launch vehicle integration video will be presented.
View of GSLV F-16 mission here at Satish Dhawan Space Center, Sriharikota. The launch campaign begins with the flag off of the nozzle end segment from its preparation building to the vehicle assembly building, where it is being handled and carefully positioned on the mobile launch pedestal. The first stage of GSLV consists of 5 solid motor segments which have a case bonded HTPB based solid propellant. It has a nozzle end segment, 3 middle segments and 1 head end segment. On your screens now is the handling of head end segment. That is the igniter being integrated on the top of the first stage motor, the interstage 1-2. It is a vented interstage to enable hot separation of GS1. The strap-on motors called the L40s being prepared in a sprayed building, handled and moved to the vehicle assembly building to be tilted and then assembled with the core motor. L40 strap-ons in GSLV. You can see on your screens it has completely been assembled.
अभी आपने प्रथम चरण का
You see first stage combination
प्रयोग करते हैं और अभी आप देख रहे हैं यह द्वितीय चरण है।
You're seeing second phase GSLV Mark II.
GS2 HT कहते हैं।
We say GS2 ST.
चरण है और इसमें आप देख सकते हैं
This is the liquid propeller.
इसमें भारत पूरी तरह स्वायत्त प्राप्त कर पाया है। इसके पूर्ण परीक्षण के पश्चात
after the full experiment,
अंतरिक्ष केंद्र लाया जाता है। आगे के परीक्षण के पश्चात इसे यान में।
So after the further experiment,
क्रायो स्टेज है, तृतीय चरण है।
This is the cryo stage, third stage GSLV.
जो
This is the last stage
प्रयोग करता है,
which is a cryo fuel.
ऑक्सीजन तथा
is used liquid oxygen and liquid hydrogen
या अंतिम
will be combinedly used. This is the last stage.
इसके ऊपर में
So on top of this,
उपग्रह को समायोजित किया जाएगा और यह है।
So it will be combined here.
On your screens now,
NISAR.
spacecraft NISAR. In the visuals before this, you have watched the integration of the second stage of being operated on a storable propellant and then the cryo stage, and these are the visuals. Craft preparation facility, the clean room where the encapsulation of the spacecraft is taking place.
पूर्ण परीक्षण के पश्चात
after the full experiment,
कर दिया गया है।
this satellite will be encapsulated.
vehicle assembly building लाया जा रहा है।
So VAB vehicle assembly building has been brought after careful security and quality. It will be combined with the space vehicle.
और इस तरह पूरी तरह तैयार
In this way, fully prepared
GSLV
for this completion of the mission
BAB से
F-16
UT की तरफ लाया जा रहा है umbilical tower की तरफ
towards the tower. It has
the movement of the fully integrated GSLV F-16 to the umbilical tower of the second launch pad.
आगे की गतिविधियां तथा परीक्षण
so further activities and the experiment will be done with the tower.
जांच यहाँ से पूरी की जाएंगी.
So all the health checkup will be completed here.
We are about 20 minutes away from the launch. The countdown for this mission was 27.5 hours long, and it had started yesterday, that is the 29th at 14:10 hours here.
GSLV F-16
GSLV F-16
गिनती 27.5 घंटे पूर्व.
The countdown will be 27.5 have been started.
अभी आप सभी दर्शकों ने सुना रेंज ऑफ
You have seen you have
मिशन डायरेक्टर को दे दी है.
mission director has given the information.
उड़ान की उल्टी गिनती जारी है और
the countdown is continued
जारी है
of this space vehicle.
स्वचालित प्रक्षेपण अनुक्रम यानी ऑटोमेटिक लॉन्च सीक्वेंस शुरू किया जाएगा.
Automatic launch sequence is going to be started.
इस दौरान यान निदेशक
This way the director
एलिमेंट्री ट्रैकिंग कमांड
मिशन डायरेक्टर रॉजर
और सैटेलाइट डायरेक्टर
satellite director
mission
are also giving the information to the mission director.
During the countdown, the servicing operations for the Earth storable propellants into the GS2 stage and the 4 numbers of L-40 strap-ons was carried out. Health checks were carried out on the spacecraft and the launch vehicle. The meteorology instruments will indicate crucial data to comply to the launch commit criteria. Radars carry out transmission checks and cryopropellants are serviced few hours ahead of launch.
Mission Readiness Review Committee and the Launch Authorization Board have granted clearance to proceed with the countdown and launch of GSLV F-16 NISR mission. All operations up to the initiation of automatic launch sequence have been completed satisfactorily. Based on the clearances received for the launch vehicle, spacecraft, range systems, ISRA ground stations, and considering the favorable weather conditions, Mission Director hereby authorized the commencement of launch operation sequence for the GSLV F-16 NISR mission at 17 hours, 40 minutes and 25 seconds IST, today, the 30th July 2025. This is Vehicle Director. Pre-launch operations of cryo stage is authorized.
Note, Mission Director has given authorization for the launch of GSLV F-16 NISR mission.
आप सभी दर्शकों ने सुना
सभी all the viewers have heard
से कार्य करते हुए और उनके तंत्रों की
मिशन
निदेशक तक पहुंच
combinedly working.
पश्चात मिशन निदेशक
The information has already been disseminated.
अनुमोदन प्रदान कर दिया है.
So the approval has been given.
Automatic launch sequence has been authorized by the mission director. In the preceding 14 minutes before launch, a capsule of crucial functional aspects of launch vehicle systems, which includes actuation of liquid stage engine actuators, health confirmation of ground systems that are crucial for the launch, and very close to T0, control is passed on to the onboard computers.
अब हम उड़ान से 17 मिनट की दूरी पर हैं.
We are 17 minutes away from the launch.
होने के पश्चात यान को पावर
So after the GS countdown has been begun.
द्वितीय चरण जो है तरल
GS2 second stage.
उसके बाद L-40 चरणों में
after this L-40 stage
उसमें भी तरल नोदक का भराव सुनिश्चित किया गया. मिशन कंप्यूटर और
propeller
की स्वास्थ्य जांच की गई. क्रायो आर्म
the health has been checked up.
फिलिंग के लिए तैयार.
Operation is the filling has been prepared and it has been assured.
स्वास्थ्य जांच पूरी की जा चुकी है. एयर ट्रैफिक कंट्रोलर तथा
air traffic controllers
अनुमति
and
प्राप्त की जा चुकी है। हमारे मौसम विभाग से भी पूर्व सूचना प्राप्त की गई है और इस दौरान मौसम पूरी तरह
weather is
अनुकूल बताया गया है।
ideal for the launch.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है।
Automatic launch sequence is continuous.
-16 minutes.
ऑटोमेटिक लॉन्च सीक्वेंस
authorization
कंप्यूटर जांच पूरी की जाएगी।
initiate automatic launch sequence for the launch of GSLV F-16 NISR mission.
SDA servers activated. MC confirms data from SHAR-1 and SHAR-2.
GSLV F-16 mission at the second launch pad. It's getting ready for its first ever mission to Sun synchronous polar orbit.
Automatic launch sequence initiated for GSLV F-16 and NISR mission.
ALS in auto mode.
Operations commenced.
नाइसार उपग्रह L और S बैंड
NISR satellite
अपर्चर रडार वाला उपग्रह है जो उच्च विभेदन के साथ बड़े पैमाने को प्राप्त करने के लिए CSAR तकनीक से संचालित होगा। नासा के जेट प्रणोदन प्रयोगशाला जेट प्रोपल्शन
NASA's jet propulsion laboratory
तैयार
with ISRO. This has been prepared.
राष्ट्रीय जरूरतों को पूरा करेगा।
This not only addresses the national necessity. This will be providing the data to the whole world.
का सही सम्मिश्रण
It's a combination of two cultures and then the best creation.
.7 meter tall GSLV is a 3-stage launch vehicle of 420.5 tons lift-off mass. The first stage, GS1, comprises of S-139 solid booster and 4 strap-ons of liquid L-40. The second stage, GS2, is Earth-storable liquid stage of GL-40 HT.
L-40 EGC actuation in
The
progress.
third stage, GS3, otherwise called CUS-15, and is powered by cryogenic propellant combination of LOX and liquid hydrogen. The payload fairing is of ogive shape with 4 meter diameter.
यह रचना आपके सामने प्रस्तुत है GSLV F-16 प्रमोचयान की
GSLV F-16
7 मीटर इसका कुल उत्थापन भार
421.7 meter the height, so its mass is 420.5 tons.
स्ट्रैप-ऑन्स लगे हुए हैं। द्वितीय चरण में L-40
the second stage
ऊपर स्टेज
L-40 and then
वाला चरण है
so this is the
और ऊपर
cryo engine stage, third stage.
पूरी तरह सुरक्षित है।
So our NISR is fully protected.
Payload pairing 4 मीटर
payload pairing
वाली ओजू payload pairing
4 meter.
40 EGC actuation completed.
सभी गणमान्य व्यक्ति यहाँ उपस्थित लॉन्च का अनुभव लेने यहाँ
everybody are attending, the distinguished guests.
GSLV F-16 की उड़ान दक्षिणी
GSLV F-16 flight would be from the south direction to keep it in the tracking range. Radar tracking station
मॉरिशस और अंटार्कटिका में स्थित हैं।
Antarctica,
निगरानी रखेंगे
Mauritius.
हम तक सभी आंकड़े वास्तविक समय पर उपलब्ध
So we will be getting all the data on the real time.
We are 11 minutes 45 seconds from the launch. In the preceding several months, both ISRO and NASA have disseminated information and data characteristics to enable prospective users to take full advantage of the data gathered by NISR when it becomes available.
सभी वैज्ञानिक अपने कंसोल पर
all the scientists are studying their data.
अभी तक
all the technologies are working fine.
लॉन्च व्यू गैलरी का दृश्य
You're seeing the gallery of the launch, the encouragement, all the students here, big numbers they've been presented here, they're gathered here
अनुभव लेने के लिए
to experience the
अनुभव होता है अपनी आंखों से
launch of this satellite.
स्वानुभव लेने वाला यह पल
Exuberant spirits of the students here at the Launch View Gallery at Sriharikota.
उत्साह देखते ही बनता है छात्रों का
So the inspired students encouraged here.
पल मिला है जब
This is the moment they've been getting.
यह प्रमोशन देख सकते हैं
You can see this launch.
T-minus 10 minutes.
GS2 radar engine actuation in progress.
ISRO is bringing to you a curtain raiser for the mission NISAR for your better understanding about the mission.
In an era where climate change dominates global discourse, humanity faces an increasing vulnerability to natural disasters. To address these mounting challenges, NASA and ISRO have joined forces in an extraordinary collaboration to launch the NASA-ISRO Synthetic Aperture Radar Satellite, NISAR. This groundbreaking low Earth orbit LEO observatory promises to revolutionize the way we understand our dynamic planet. Equipped with state-of-the-art LNS band synthetic aperture radar, SAR systems, NISAR will use the sweep SAR technique to deliver high-resolution images across vast swaths of the Earth's surface. Incredibly, it will map the entire globe every 12 days, offering unprecedented consistency in spatial and temporal data. NISAR's mission is nothing short of transformative. From tracking glacial melt and monitoring agricultural landscapes to analyzing seismic shifts and managing disaster response, it will empower scientists, researchers, and policymakers with vital insights. By precisely measuring minuscule movements and colossal environmental events alike, NISAR will help us decode Earth's complex ecosystems and natural hazards. The flagship mission sees NASA contributing the L-band SAR, engineering payloads, critical systems like GPS receivers, and the solid-state recorder. ISRO supplying the S-band SAR, spacecraft bus, and will launch the satellite aboard through its vehicle GSLV F-16 from Sriharikota. A majestic 12-meter unfurlable reflector antenna will unite the dual-band systems, enabling powerful Earth observations from orbit. The geosynchronous satellite launch vehicle, GSLV F-16, features a 3-stage configuration. Its first stage comprises a solid rocket motor at the core, support 4 liquid strap-on boosters. The second stage operates on liquid propellant, while the third and final stage is powered by an indigenously developed cryogenic upper stage. The payload fairing for the GSLV F-16 NISAR mission features a 4-meter diameter OGIV configuration. The launch will take place from the second launch pad at India's spaceport, SDSC Shar at Sriharikota. It is the first GSLV mission to be launched into a sun-synchronous polar orbit. NISAR is not just a satellite, it's a symbol of global unity, scientific excellence, and hope. It promises to safeguard our future by helping humanity live more wisely with nature.
ऑटोमेटिक लॉन्च सीक्वेंस जारी है और अब हम 6
automatic launch sequence is continuous. We are 6 minutes away from the launch.
का विवरण देते हैं GSLV
So we will give you the details of this launching.
से बना हुआ प्रौंच ज्ञान है प्रथम चरण में
So 3 stages. Stage 139
है जो कि PSLV से व्युत्पन्न
which is PSLV 7.
प्रथम चरण के साथ 4
The first stage, so the liquid propeller will be used L40
संचालित किए जाते हैं 4 S130
gas engine
मोटर के साथ मिलकर कुल 8000 किलो न्यूटन का प्रणोद उत्पन्न करते हैं
8000 किलो न्यूटन
आवश्यक होता है यान के उत्थापन
this is required for the lift of the spacecraft.
किलोमीटर की ऊंचाई प्रदान करेगा तथा इस समय
54 kilometer height.
L40 strap on
L40 is strap on
प्रज्वलित रहता है
150 seconds.
मिलीसेकंड बाद द्वितीय चरण प्रज्वलित होता है और इसके तुरंत बाद प्रथम चरण के यान से पृथक कर दिया जाता है
So it will be separated from the first.
वाला चरण है
So again, second stage is the liquid
द्वितीय चरण
stage.
विकास इंजन के साथ 846 किलो न्यूटन का प्रणोद उत्पन्न
846 किलो न्यूटन
प्रज्वलित
146 seconds. It will be ignited 3.5 kilometer per second relative velocity.
यान से ऊष्मा कवच यानी
during the second stage.
क्लोज लूप गाइडेंस के अंतर्गत अपना दिशा निर्देश द्वितीय चरण की समाप्ति के पूर्व ही तृतीय चरण
after the completion of second stage, the third stage will be started. The cryogenic fuel
और सबसे जटिल
GSLV, the third and the last stage.
चरण के पूर्ण प्रज्वलन
in this cryo stage, the ignition
अतिरिक्त प्रणोद के लिए कमांड दिया जाएगा.
So the command will be given for 11% additional
75 किलो न्यूटन का प्रणोद करता है. इस तरह
onboard computer by this way
यान लगभग 400 सेकंड में 780 किलोमीटर की ऊंचाई प्राप्त कर चुका होगा और सापेक्ष गति 4.57 किलोमीटर प्रति सेकंड. इसके पश्चात क्रायो चरण को पुनः सामान्य प्रणोद के लिए कार्यशील किया जाएगा और फिर 400 सेकंड
after that 400 second 7.5 kilometer per second relative velocity will be applied.
स्थितियां प्राप्त करेगा.
So it will be getting
1115 सेकंड पर पूरा किया जाएगा.
All these activities will be completed.
Let us take a quick look at the mission events for GSLV F-16 NISAR mission. The L-40 strap-ons ignite 4.8 seconds ahead of T0 so that their nominal thrust can before igniting the booster. Liftoff coincides with the ignition of S-139, also called as GS-1 at T0. The burn time of GS-1 is 112 seconds and that of the L-40s is 149 seconds. By the time GS-1 and L-40s finish their operation, the launch vehicle is at 104 kilometers altitude. In a staging event typically called as hot separation, the GS-2 stage is ignited 600 milliseconds after the L-40 thrust cutoff and 1.6 seconds later the stage separation takes place. When the launch vehicle reaches 138 kilometers altitude, the dense atmosphere would have cleared. Since the need for thermal shielding and aerodynamic shape is no longer significant, the payload fairing is jettisoned. Closed loop guidance also is initiated. At this point of time in the mission, the launch vehicle would have acquired 2.1 kilometers per second relative velocity. For the present mission, the burn time for GS2 is 140 seconds. It is separated 4 minutes 53 seconds into the flight. The third stage is the cryogenic upper stage, which plays a significant role in the mission. Its high specific impulse, together with a long burn time of more than 13 minutes, it adds tremendous relative velocity to the cusp operation adds 376.55 kilometers
stand by for the time mark.
And increases relative velocity from 3.5 kilometers per second to 7.5 kilometers per second. An operational philosophy unique to the GSLV F-16 ISR mission is that cusp stage is operated by 11% for the duration of 405 seconds. About 11 minutes into flight, the cryogenic upper stage shuts down. The satellite NISAR is separated, injected into an altitude of 745.5 kilometers with a relative velocity of 7.57 kilometers per second.
Minus 25 seconds.
We are mere 25 seconds from the launch.
Minus 20 seconds.
सभी दर्शक हमारे साथ बने रहिए.
So please stay tuned with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
All L40 engines generating nominal thrust. S139 motor ignited.
That's a magnificent of the GSLV F-16 NISAR mission. The deafening roar of GSLV and beautiful silhouette brightening the Sriharikota sky.
जी हाँ, अभी आपने देखा चारों
You see L40
सफल प्रज्वलन और GSLV
successful launching the
की ओर बढ़ता हुआ.
This is going to the destination.
हम यहाँ कंपन महसूस कर पा रहे हैं.
We are experiencing the vibration here in this mission station.
139 solid core motor and 4 L40 liquid strap-ons thrusting together. 7,800 kilonewton cumulative thrust.
First stage performance normal.
Sharon is in Venado.
The day of launch wind biasing program that is fed into the onboard computers helped the rocket to veer through the atmosphere with minimal aerodynamic loads.
प्रथम चरण का कोर बूस्टर लगभग
The first stage core booster will be ignited.
L40 चरण
L40 stage 150 seconds it will be calm. So after that it will be separated from the craft.
अपेक्षित पथ का अनुकरण करता हुआ.
First stage performance normal.
Currently the rocket is in open loop guidance. Shar ground station is tracking.
S139 burnout.
कोर बूस्टर का प्रज्वलन समाप्त हो चुका है.
So it has been completed. The
Director that
ignition of core booster
has stopped its operation. The 4 L40s are thrusting still.
First stage performance normal.
प्रथम चरण का कार्य निष्पादन पूरी तरह सामान्य.
The first stage is normal. This is going to its launched direction. L40 is ignited. So it will be 50 seconds duration.
GS2 ignited. GS1 separated. 1S. IS 1/2 main separated.
जी हाँ, अभी आपने सुना रेंज ऑपरेशन.
Yes, you saw.
पुष्टि की है.
Range operation director has
किया जा चुका है.
Payload fairing.
प्रज्वलन शुरू हो चुका है.
The second stage ignition has been started.
Flight. The GS1 has undergone a hot separation and GS2 commenced its operation and thrusting nominally. The payload fairing has also been separated and closed loop guidance has been initiated.
जी हाँ, इस दौरान
वातावरण
से बाहर, इसलिए पेलोड फेयरिंग या ऊष्मा कवच की आवश्यकता, इसलिए इसे यान से पृथक कर दिया जाता है.
So this has been separated from the
अंतर्गत है और स्वतः ही
spacecraft,
कर रहा है.
and then this is going to its own direction.
That uses the Earth storable propellant combination of UH-25 and N2O4. The second stage of GSLV develops 846 kilonewton thrust in vacuum. Burn time for this mission of GS2 is 140 seconds.
Plus 4 minutes.
दर्शकों का उत्साह देखते ही बनता है यहाँ पर.
So we are seeing the encouraging viewers here.
द्वितीय चरण सामान्य निष्पादन करता हुआ.
The second stage is in its normal ignition.
इसमें इस चरण में UH-25 N2O4 ईंधन का प्रयोग किया जाता है.
In this stage, UH-24 and N2 is used.
लगभग 150 सेकंड का होगा.
So around 150 seconds time for this ignition. Like we previously mentioned, second stage.
चरण को अनुमोदित कर दिया जाएगा.
So after finishing the second stage, the third stage would be started.
GS2 thrust cutoff.
The
GS2 separate. Cut stage ignition commanded.
Jettison from the ongoing vehicle.
द्वितीय चरण के सफलतापूर्वक प्रदर्शन के पश्चात
second stage completion, successful completion has been achieved. This is the third stage, the last stage has been, this is the complex stage. So we can see the viewers encouraging viewers.
Operation.
Cryo stage operating at operated level.
The cut stage with CE 7.5 engine with liquid hydrogen as fuel and liquid oxygen as oxidizer with a nominal thrust of 73.55 kilonewton. In this mission there will be a thrust upratement of 11%, that is
Cryo stage performance normal.
kilonewtons for about 405 seconds.
Plus 6 minutes.
वर्तमान में तृतीय चरण क्रायो अपर स्टेज.
This is the third stage.
किलोन्यूटन का प्रणोद उत्पन्न कर रहा है.
75 kilonewton ignition.
800 मिनट सेकंड्स तक जारी रहेगा.
So this will be continued for 850 seconds.
वर्तमान में सापेक्ष गति 3.49 किलोमीटर प्रति सेकंड तथा
So currently the relative velocity is 3.49 kilometer per second.
Cryo stage performance normal.
Altitude of 528 kilometers. Shar and Trivandrum stations continue to extend tracking and telemetry support. When the cryo stage had commenced action, the instantaneous relative velocity was 3.5 kilometers per second. By the end of thrust upratement, it becomes 4.5 kilometers per second. For the next 400 seconds that follow, there is a significant addition in the relative velocity of up to 7.5 kilometers per second.
Cryo stage performance normal.
सभी विशिष्ट वैज्ञानिक यहाँ उपस्थित.
So specific scientists are present here to witness this great event. So the third stage is completely normal.
इसे भलीभांति ट्रैक कर रहे हैं.
So they are tracking.
The altitude gained during thrust upratement is about 400 kilometers in cryostage operational range. When the thrust upratement ends, there is a considerable increase in relative velocity at a marginal loss of altitude.
Plus 8 minutes.
तृतीय चरण की यात्रा लगभग 850 सेकंड तक जारी रहेगी.
So the third stage would be continued up until 850 seconds.
Cryo stage performance normal.
जिसे संक्षिप्त में नाइसार कहते हैं. वैज्ञानिकों को प्राकृतिक खतरों
This is called NISAR.
घटनाओं जैसे भूकंप, ज्वालामुखी विस्फोट और भूस्खलन जैसी प्राकृतिक घटनाओं को बेहतर ढंग से समझने के लिए
natural disasters like landslide
भेदने की क्षमता के कारण यह तूफान और बाढ़ जैसी मौसम
this penetrates the clouds
सटीक जानकारी उपलब्ध कराने में
and this will provide the real-time information about
मदद मिलेगी। यह बर्फ की चादर, ग्लेशियर और समुद्री बर्फ में परिवर्तन जैसे
the changes in the glaciers, the thickness of ice,
वनों की कटाई, वनाग्नि तथा
ढकी हुई deforestation.
यह एक अग्रणी
The problems of deforestation can also be mitigated.
बारे में वैज्ञानिक जानकारी का खजाना प्रदान करेगा।
So this will provide the scientific information.
वैज्ञानिक आपस में जुड़ चुके हैं तथा आपसी
the scientists are combined together, so this is a very ambitious mission.
NISAR, or the NASA ISRO Synthetic Aperture Radar, is a remarkable milestone in the Indo-US space ties. Designed on the I-3K mainframe bus, NISAR will render services for the next 5 years according to free and open data policy. NISAR provides a means of disentangling and clarifying spatially and temporally complex phenomena ranging from ecosystem disturbances to ice sheet collapse and natural hazards including earthquakes, tsunamis, volcanoes and landslides. ISRO has identified a range of applications of particular relevance to India that the
Cryostage performance normal,
including monitoring agricultural biomass over India, monitoring and assessing disasters to which India responds, studying snow and glaciers in the Himalayas, and studying Indian coastal and near-shore oceans by monitoring annual changes in bathymetry along the deltaic regions, shoreline and accretion. The changes that Earth is undergoing in its ecosystem, deformation and cryospheric sciences emphasizes the urgent and constant need to observe Earth from the vantage of space in order to thrive on our changing planets in decades to come. NISAR offers centimeter-level precision capable of detecting subtle ground shifts and environmental changes. Data from NISAR will provide critical insights to help India and US plan for natural
cryostage performance normal.
Today, when the GSLV F-16 rocket of ISRO places NISAR in its intended orbit, a critical deployment event, that is, of the 12-meter wide mesh reflector will take place. This mesh reflector acts as a radar antenna. The deployment will be a slow sequence to ensure the delicate boom and antenna unfold without damage or misalignment. The deployment will begin 10 days after launch and will be carried out over the next 8 days.
Plus 12 minutes.
To prepare NISAR for science operations, in-orbit checkout, physical deployment of all deployable parts, checking out the engineering systems, testing the radars independently and jointly, this phase will last for 90 days after the launch. Extensive calibration and validation activities will take place throughout the first 5 months. The schedule of science observations alone will be driven by a variety of inputs, including L and S band target maps, radar mode tables, and spacecraft and ground station constraints and capabilities.
तृतीय चरण क्रायोपर स्टेज
Third stage, cryo stage, ignition is completely normal. The relative velocity
तथा
4.9 kilometer per second, and altitude is 788 kilometer.
पृथ्वी की भूमि तथा बर्फ का अध्ययन करने के लिए सिंथेटिक अपर्चर रडार
To synthetic aperture radar capacity is used.
और फिर
So this will give the data.
संकेतों को प्राप्त कर 3D चित्र
Changed signals will be sent.
12 मीटर व्यास वाले unfurlable.
So there is a 12-meter wide reflector antenna is attached.
में 2 बार एक ही जगह से निकल सकता
2 times.
और इस समय में जितने बदलाव से पृथ्वी में की सतह पर आए बदलाव नाइसार
study
और इसरो द्वारा तैयार रडार प्रणाली वाला उपग्रह है.
This is
सिंथेटिक अपर्चर रडार की तुलना में अत्यधिक शक्तिशाली है.
This is a very powerful synthetic radars available here. This is the
L-band
25 centimeter wavelength L-band radar system used by NASA.
S-band radar system.
So the other one is the NISAR.
जैसे कि मिट्टी में नमी, सतह का खुरदरापन और गति. निसार सूर्य तुल्यकालिक कक्षा में काम करने जा रहा है. इसके एंटीना एक खास विन्यास में.
Its antenna is
अभूतपूर्व
Antarctica.
यह अंटार्कटिका.
We can observe the Antarctica as well.
अध्ययन के लिए बहुत महत्वपूर्ण माना जा रहा है.
This is very important to study the melting of ice in Antarctica as well.
के मुख्य मिशन के दौरान
So 3 years main mission the data would be provided.
के बराबर है. इतने
So this is the 80 terabyte data.
संग्रहित और वितरित किया जाएगा.
This will be distributed.
सभी S-band और L-band data.
All the S-band and L-band data will be national remote sensing, and so government of India will be used.
Synthetic aperture radar.
It will be provided to other countries as well.
NASA ने 1900.
NASA has 1978. They have started.
ने विमान व अंतरिक्ष से विज्ञान क्षेत्रों के अध्ययन के लिए अग्रणी रहे हैं.
For the study of space.
विस्तृत श्रृंखला 2012 में रडार
2012
और 2001
in 2000.
नाइसार व्यापक के साथ उच्च रिजोल्यूशन के डेटा निरंतर.
So high resolution data would be available.
We are 16 minutes 15 seconds past the launch. Now the cryogenic upper stage is currently thrusting. Vehicle trajectory correctly follows the prediction.
Cryo stage performance normal.
तृतीय व अंतिम चरण GSLV Mark II का क्रायो अपर स्टेज के नाम से जाना जाता है.
Cryo upper stage
में पूरी तरह
currently completely normal performance. All the
सामान्य निष्पादन करते हुए
system
यान को उद्दिष्ट कक्षा की ओर.
So the vehicle is targeted to the designated orbit.
कक्षा की स्थितियां प्राप्त करते ही क्रायोजेनिक इंजन को बंद कर दिया जाएगा.
Cryogenic engine would be closed.
The launch vehicle is at an altitude of 748 kilometers.
कक्षा की स्थितियां प्राप्त होते ही
as soon as the situation in the orbit.
Satellite separation event.
Cryo stage performance normal.
Plus 18 minutes.
वर्तमान में सापेक्ष गति 7.5 किलोमीटर प्रति सेकंड तथा ऊंचाई 745 किलोमीटर होती है.
Performance normal.
So currently 7.35 kilometer per second is the relative velocity, and
performing nominally.
Stage thrust cut off.
The thrust has cut off of cryo stage, and next event is the NISAR separation, which is perhaps
जी हाँ, जैसा अपेक्षित था.
Yes, as expected.
इसकी पुष्टि हो चुकी है.
This has been confirmed. The NISR has been separated.
The NISR satellite into its designated injection orbit. The GSLV F-16 NISR mission is successfully accomplished.
History has been written today as NISR has been placed in the orbit successfully. Many hearty congratulations to ISRO, NASA, and the users worldwide who will derive benefits of the Earth observation with this state-of-the-art NASA ISRO synthetic aperture radar satellite. Do stay tuned. Tune in for the address by Secretary DOS and Chairman ISRO and mission executives. We take leave from you. Namaskar.
Yes, प्रक्षेपण के साथ नाइसार का प्रमोशन.
With this launching, the launch mission has been successful.
शुभकामनाएं.
So congratulations to all the viewers and the scientists. So we will be taking you to the address of the scientists.
CS announced. the director of the satellite department. Very good evening to all of you. I am extremely happy to announce that GSLV F-16 vehicle has successfully and precisely injected the NASA ISRO synthetic aperture radar satellite NISR satellite weighing 2,300 kg into its intended orbit. Let me congratulate all the teams from ISRO and NASA JPL on this outstanding success. This is our 102nd launch from Sriharikota and the 18th mission of GSLV. As all of you may recall, we had the previous GSLV F-15 mission on 29th January 2025, which was the 100th successful mission launched from Sriharikota, and also the first launch after the new management, including me, took over as the chairman of ISRO. This is the first GSLV mission to the Sun synchronous polar orbit. Till date, all the GSLV missions have been to GTO. Being the first SSPO mission, several analyses and studies were carried out to make this mission a grand successful mission, including the cryogenic upper stage corrections. A host of mission simulations were carried out very systematically and meticulously, and today's successful mission is accomplished. All the vehicle system performance were quite normal, as expected and as predicted. And today we achieved the intended orbit. Actually, we have got the orbit position of less than 3 kilometers as against the permissible level of 20 kilometers. The specification is 742 kilometers. We have got 740 kilometers. Apogee 745 kilometers is the specification. We have got 747 kilometers. And all the parameters are as expected and in the right line. And this accomplishment is a teamwork, culmination of the teamwork of both ISRO and JPL NASA. The NISR satellite is a significant milestone for both Department of Space and NASA JPL, being the first joint development project undertaken by the two major spacefaring nations. NISR is an all-weather, day-night imaging satellite that will scan the entire Earth at 12-day interval. The satellite integrates ISRO's S-band synthetic aperture radar payload with NASA's L-band SAR payload and 12-meter unfurlable reflected antenna to become the first of its kind, a dual-frequency SAR satellite. NISR will enable the scientific community to detect the surface variations, sea ice detection, invest natural hazards, monitor soil moisture, and many other applications. The potential applications from the satellite are huge, and the global scientific community is eagerly awaiting the satellite data for their respective research and usage. The implementation arrangement between ISRO and NASA for a joint Earth observation satellite mission was signed on 30th September 2014. Between then, it was signed by the then Chairman ISRO, Secretary Department of Space, Dr. K. Radhakrishnan, who is sitting in front of us, and with the NASA Administrator, Mr. Charles Boulder. In fact, we were so happy to participate in that function which happened in Toronto. Since then, the realization of satellite in ISRO progressed steadily under the outstanding leadership of subsequent chairman, Sri Kiran Kumar sir, who is also present in the audience, Dr. K. Sivan, Dr. Somnath, and also under different project directors. On this occasion, let me congratulate all of them. Also salute each and every one of the team members who have contributed for this significant achievement. Let me also congratulate all the technical teams, administrative teams both in NASA, JPL and ISRO, who worked shoulder to shoulder to build the satellite at UR Rao Satellite Center. over the past so many years. Our mission has brought the two space agencies much closer than ever before, and the continuous interactions at various levels during the course of project execution has enriched both sides. On behalf of Department of Space and ISRO, let me thank the NASA JPL team and all other stakeholders in the project for their excellent contribution to the joint mission. Also congratulate them on the successful launch. We wish the scientific community from both sides the exciting days ahead. Let me also congratulate the ISRO teams from SAT, URSC, VSSC, IASU, IPRC, LPSC, ISTRAC, and all the teams involved in the payload development, satellite integration, realization of solid, liquid, and cryogenic stages, inertial systems, and the launch vehicle itself. Let me take the opportunity to congratulate the Chairman Launch Authorization Board, all the center directors who are with me. It's a teamwork done by ISRO along with the NASA. I express my heartfelt gratitude to the Honorable Prime Minister, Sri Narendra Modi ji, who as the Minister of Space has provided outstanding, encouraging support for the entire project for its successful execution today. Also, let me thank Honorable Minister of State, Dr. Jitendra Singh ji, officials, PMO officials who are working hand in hand with the Department of Space, and all our family members, entire team members of ISRO, and the academia and industrial participants who have contributed for this. I think at this point of time, this success is demonstrating a teamwork, a international teamwork between two spacefaring nations, and surely this data is going to be highly useful for the scientific community of the globe. And when every 12 days when the data is going to come, it is not going to be used by one or two countries. The entire globe is going to benefit out of this great accomplishment. And at this point, once again, let me congratulate all the team members, our family members, industrial partners, academia team, and the NASA team for the outstanding work. At this point, before I hand over to my team, let me invite Cassie Swales, Deputy Assistant Administrator at NASA, for expressing her thoughts on the journey so far in this joint outstanding mission. Madam, please, floor is yours.
Well, I first have to start with go ISRO, go NASA, go NISAR. So I am honored to be here today in the ISRO Mission Control Center. It's just truly been an incredible visit so far, and I have to tell you, I had an opportunity. I'm sitting next to our charge. It's just an honor to have you here, so thank you, sir, for being here. The former ISRO chairman, I looked at him right after the launch, and I said, so how does it feel to not be on console? He said, well, it's a different seat, so it's good to not be in the hot seat. So I'm glad you got to watch the launch and enjoy it. But on behalf of NASA, I want to congratulate all of the teams. It has been just an incredible decade culminating in this moment, from the technical collaborations, the cultural understandings, getting to know each other, building that team across continents, across time zones, missing nights, missing weekends with families, holidays. It is truly something that every single person in this room should be proud of. I am so proud. I was so proud to be out there watching this launch. Dragonflies flying above, it just picture perfect, and I could not be more proud of these teams. You know, and this mission, it's truly a pathfinder, not just in regards to our technical, because those are truly incredible. This Earth science mission is one of a kind and really shows the world what our two nations can do. But more so than that, it really is a pathfinder for the relationship building that we see across our two nations, you know, across India, the United States, building upon decades of collaborations that already exist. And I cannot be more proud to be here representing the U.S. and really representing the teams that have been working so closely behind the scenes to make this happen. I also want to thank, I saw, several family members, both, last night on the U.S. side, I saw several family members here, so I want to thank the families. It's no small sacrifice seeing your loved ones work day in and day out on a mission that takes over a decade to build. So thank you for your support of the incredible, technical, talented people in this room. And I really, really cannot wait for continued partnerships as we go forward, building on Chandrayaan, Axiom 4, and now NISAR. So thank you. Congratulations. Go NISAR. Go India. Go the United States.
Congratulations. Now,
if you're just joining us, I'm Raquel Villanueva with Dr. Sue Owen, live from NASA's Jet Propulsion Laboratory in Southern California. We were just watching celebratory speeches from India after our colleagues at the Indian Space Research Organization launched NISAR about 30 minutes ago. NISAR is a joint mission between NASA and ISRO. It's a powerful Earth-observing satellite built to track changes on our planet. And launch was a spectacular sight. Right, Sue?
It was really amazing. And, we were here at the Mission Control Center here watching the launch, and it was just so exciting. We had our lucky peanuts. It's a special NASA tradition to have peanuts for launch. And so, it was really moving to see NISAR finally making its way into space.
It was great to see you get emotional watching it too, eating your lucky peanuts. And we weren't the only ones celebrating here at JPL. Here's a look at our mission control and friends and family inside Von Karman Auditorium reacting to launch.
Yeah, everybody was just so excited. You can see people clapping and cheering. It was a great event.
I know, we're right next door to the mission control, so we could really hear them cheering at each milestone. Now, our home planet is constantly changing in a variety of ways, some subtle, others dramatic. NISAR will enable us to comprehensively monitor Earth's land and ice surfaces, building a detailed record of large and small changes over time.
With NISAR, we're tracking the changes of the solid Earth and how it's moving, ecosystems, ice cover, and any other thing that's changing at the scale of a centimeter on the Earth in a way that we've never been able to see before. Because of these very subtle motions we can measure, we're able to understand what's happening below the surface of the Earth at great precision. We can see subsidence, and that allows us then to manage resources of what's happening below the Earth.
Scientists want to study the movements of the Earth's surface to understand the processes that could trigger earthquakes, volcanoes, and landslides.
And that allows us then to understand risks associated with natural hazards,
which in turn can help in mitigation measures and early response. Other changes over the Earth's surface include melting of glaciers and ice sheets, changes in forest biomass, soil moisture, and shoreline changes.
It's based on radar, so it has two different frequency radars, and it basically looks through clouds and sees the surface of the Earth. What you're seeing is an animation of how the radar collects data, and you can see these beams coming down from the antenna and coming back, and on the ground you can see the swath, and that's where it collects the data, and when it combines them all together you get what we need for the science.
We can see day and night through clouds, and we're covering all of the land and all of the ice-covered surfaces of Earth every week. NISAR is quite unique in that it has two radars, one provided by NASA, one provided by ISRO, the Indian Space Research Organization.
NASA and ISRO have collaborated in this mission. Till last year we were there at JPL, NASA, where the radars got integrated and tested and were shipped back to India. And now the spacecraft is getting integrated with the instruments and they are being tested together. NISAR is going to be launched from Sriharikota, which is a ISRO launch pad, and it is going to be launched by GSLV Mark II. So we are just looking forward for the launch of NISAR in the forthcoming year.
NISR is measuring the changes on the Earth's surface, which are either factors or indicators of climate change. The society will also immensely benefit due to its contribution towards disaster management and providing food and water security.
These things are global problems that the global community needs to come together to resolve.
Now it looks like we are no more belonging to two different worlds, and we all belong to the space community. That's it.
There's the excitement about what we are going to learn that we didn't even anticipate we were going to learn.
This mission has been years in the making, and one of the people who helped bring it to life is with us right now. Charles Alachi is the former director of JPL, a member of the NISR science team, and we are sitting in a room named after him. Charles, it is great to have you with us.
Thank you, thank you.
How are you feeling after witnessing launch?
Well, to say ecstatic is an understatement. This is a great day. I want to start by thanking our colleagues in ISRO and India for the perfect launch. We have been working together on this for almost 15 years, and I was delighted to see many of the faces that we worked with, at the Indian Control Center, and many of the people here at JPL who have spent, more than a decade, including team members sitting here, spent more than a decade to make this happen. This is a great day.
Fantastic.
So, Dr. Alachi, you actually pioneered the evolution of radar technology here at JPL. How does NISR embody that tradition of innovation?
Well, it's really in the spirit of their Mighty Six, which is the spirit, of JPL. I remember when I first came here, all the radar team used to sit in one room. We were like 7, 8 people. And now you look at how much advances were made. NASA and JPL really were the foundational start of spaceborne synthetic aperture radar, starting with CSAT and a series of shuttle imaging radar missions. We developed and demonstrated multispectral, meaning colored radar. We developed the interferometric techniques that are being used now, and now using SAR for Earth observation is being used by industry, many nations who are participating in this endeavor. But NISR is going to do the next quantum jump. We are going to be able to actually map the planet every week down to changes in the centimeters. That's a fraction of an inch. So we are going to be watching our planet actually breathing, as a result of natural changes or human-driven changes, floods, pumping water. So it's really going to open a whole new domain that is going to really impact in a major way how do we observe our planet.
Thank you. That's great.
Absolutely. And, you were mentioning those small changes. So NISR will detect changes on the Earth's surface with remarkable precision. So how will NISR's data benefit society for years to come in the near future and for the future generations?
Well, let's take one example, the floods which happened recently in Texas. NISR will be able to actually monitor the changes of the area which are being flooded, even under vegetation. And then when earthquakes happen, we will be able to monitor the surface motion which results from earthquake, so we can send the information, to the rescuers, so they know where are, the major damage which have happened. Let's take example where people are pumping water, farmers are pumping water. We'll be able to monitor how much the water table is being depleted and how much is being refilled, during the winter when there are rain, both here and in India and worldwide. So I think it's going to impact us in a significant way, in a positive way, in helping us, better manage our resources, prevent, or not necessarily prevent, but actually how do we manage natural disaster. I mean, recently there was a big earthquake in Japan, in Russia. So there is possibility of tides and flooding around coastal region. So a satellite like NISR will be able to monitor that on a regular basis. So it's really going to impact not only our scientific understanding, but our day-to-day life. So I would envision that people would be getting on their iPhone, map of the region or on a global basis to see what are the changes and how do we mitigate disasters which are happening.
So many communities will benefit from NISAR's data.
Absolutely, worldwide.
Well, thank you so much for sharing your insights with us today, Charles.
Thank you very much, and go NISAR.
Go NISAR. Thank you. So, Sue, we are waiting for our ISRO colleagues to confirm acquisition of signal.
Johnson Space Center in Houston, Texas, and welcome to Mission Control as we begin our coverage today of U.S. Spacewalk 87. You are looking live inside the equipment lock of the Quest airlock of the International Space Station as two astronauts prepare to venture outside the Quest airlock a short time from now. On your screen, you see on the left is NASA astronaut Woody Hoberg, and on the right is NASA astronaut Steve Bowen, who will be today's spacewalkers. Bowen is wearing the spacesuit with the red stripes on it, and again, Bowen is on the right side of your screen and will be wearing that spacesuit with the red stripes, and Hoberg is on the left and is wearing the unmarked suit today. Today's spacewalk is expected to last about 7 hours, the focus of which will be on the starboard truss of the International Space Station to install and monitor the deployment of one of the IROSAs, or ISS rollout solar arrays, which arrived on the SpaceX cargo Dragon resupply craft on Monday to the International Space Station. Today's spacewalk is the 264th in support of space station assembly, maintenance, and upgrades. This will be the 9th spacewalk for NASA astronaut Steve Bowen and the first spacewalk for NASA astronaut Woody Hoberg. Today's spacewalk will be the 7th spacewalk in 2023 and the 5th spacewalk for Expedition 69 so far. What you're seeing on the screen here is the crew as they continue to step through procedures ahead of stepping out of the airlock a little later this morning. Right now they're completing in-suit light exercises. You can see them moving their legs and hands slightly. These movements help acclimate the crew's bodies to the lower pressure of the spacesuit and purge excess nitrogen from their blood slowly. This is required to avoid getting the bends or decompression sickness. Earlier this morning, the crew worked through procedures to pre-breathe 100% oxygen in order to purge that nitrogen from their body as well.
Pause exercise, rest 1 minute.
So again, today's spacewalk will see the crew members working to install the 5th IROSA to the International Space Station. This IROSA will be on the 1A power channel on the starboard truss of the International Space Station. And on June 15th, we'll have an additional spacewalk to install the array on the 1B power channel. These new arrays are 60 feet long by 20 feet wide and share a little more than half of the original arrays, which, as you can see in this graphic here, they lie over top of them. Each new IROSA will produce more than 20 kilowatts of electricity, and once all...
Cycle 10, this is the last cycle.
And once all those IROSAs are installed, it will enable a 30% increase in power production over the station's current arrays. Continuing to get some good views of the crew on board the International Space Station as they step through those in-suit light exercise activities.
Station Houston on basic ground 1, no action on that last caution. Ground checking it out.
Station copies, no action on that caution message.
now coming into frame is NASA astronaut Frank Rubio, who has been helping the crew step through their procedures and get suited up this morning. Rubio is in the midst of a long-duration spaceflight. By the time he lands this September, he will have spent the longest single time in space by an American astronaut, having accumulated 371 consecutive days aboard the International Space Station.
Station Houston, Space Ground 1, just more word on that last enabled caution. It was dealing with an S12 MDM, but no impacts to the EVA. Ground is still investigating.
Okay, Johnny, we copy all. Thanks so much for the words. Understand. No impact to EVA. Good to know.
The crew is continuing to work through their in-suit light exercises.
Airlock Houston, Space Ground 1, that completes the 10 cycles of in-suit light exercise. You are go for step 5 in the EMU pre-breathe.
And the crew has completed their cycles of those aisle exercises. The next steps for them will include continuing to step through procedures ahead of depressurization, part of which will include getting their SAFERs, or Simplified Aid for EVA Rescue, installed on the back of their spacesuits. The SAFER is essentially a jetpack that could be used in the very unlikely situation that a crew member were to become untethered.
Thanks so much.
And we also have United Arab Emirates astronaut Sultan Al Mayadi floating in.
And waiting on your go for stepping.
Again, both Rubio and Alnayati helping to step through procedures with the crew as they continue preparations to exit the Quest airlock later this morning.
Frank, Step 8 is in work. It's going to take about 10 minutes. You are go to proceed in Step 9. We'll let you know when Step 8 is complete. I'm sorry, Step 7. We'll let you know when Step 7
we'll leave Texas on and proceed with Step 9.
And getting a good view of some of the tools that will be used during today's spacewalk. You did see the space drill or the pistol grip tool, which will be utilized quite heavily throughout today's spacewalk. You're also seeing some of the tethers float. Those will be utilized to ensure that the crew is attached to the International Space Station at all times. And Rubio is working to get those tools secured to NASA astronaut Woody Hoberg's spacesuit. Rubio now moving over to get those tools in place on Steve Bowen's spacesuit. And he's being assisted by UAE or United Arab Emirates astronaut Sultan Al-Nayati. Al-Nayati's on the left of your screen and Rubio's on the right. as the crew continues to step through those procedures to get tools secured safely to their spacesuits, we do have a video that will be an overview of today's spacewalk, where the duo will exit the station's Quest airlock to install an upgraded International Space Station rollout solar array on the 1A power channel on the starboard truss of the station. So let's learn a little bit more about what the crew will do during today's spacewalk.
This video is for the ISS Rollout Solar Array, or IROSA, 1A install EVA. Steve Bowen, EV1 with the red stripes, egresses and receives a crew lock bag and puts it on his body restraint tether. EV2 with white stripes, Woody Hoberg, egresses with the crew lock bag on his body restraint tether and closes the thermal cover. EV1 translates up the forward face of the truss and goes starboard. He stops to configure safety tethers. EV2 follows a similar translation path and goes to the port crew equipment translation aid cart to temporarily stow his bag and retrieve an articulating portable foot restraint. Meanwhile, EV1 translates to the IROSA carrier, stows his bag, and retrieves his pistol grip tool. EV1 begins preparing IROSA for removal from the carrier, first releasing a restraint bolt on the upper IROSA. EV2 relocates the foot restraint and installs it on the space station's robotic arm. EV2 ingresses the foot restraint, and then the arm will move him away from the truss. EV1 translates to the lower IROSA and releases its first restraint bolt. He releases both anti-rotation devices back on the upper IROSA, and then will stow them in the crew lock bag. On the robotic arm, EV2 is flown over to access two sets of bolts on the boom end of the upper IROSA. The first two bolts will allow the boom deployment system rollers to be moved into place to help with the array deployment later in the spacewalk. The second two bolts will release two of four mechanisms that hold the IROSA in its rolled-up configuration. EV1 partially releases the upper IROSA's restraint bolt and installs the first of two handling aids called scoops and prep for removing IROSA from the carrier. The arm flies EV2 over to the hinge end of the upper IROSA, and both crew members work to release the final bolt holding it to the carrier. EV1 installs a second scoop, and EV2 lifts the IROSA off of the carrier. After several maneuvers on the robotic arm, EV2 will arrive at the 1A modkit worksite. During these maneuvers, EV1 will pick up the temporarily stowed bag from the port cart and reconfigure both crews' safety tethers, on his way to meet EV2 at the modkit. Both crew will then work to install IROSA onto the 1A mounting bracket. The crew will release the scoops, and EV2 will move into position to release the final bolt, holding IROSA in its folded position. Once released, EV1 will hold IROSA closed while EV2 egresses his foot restraint and gets into position. Both crew will then work together to unfold IROSA and secure the right side onto the mounting bracket. Once secured, EV2 will drive two hinge bolts that hold IROSA in the unfolded position. EV2 will then move away from IROSA to reconfigure a safety tether on the arm. EV1 works to drive 8 bolts to fully secure the IROSA to the mounting bracket. Both crew will then work to electrically connect the new IROSA to the ISS power system. They'll first attach 4 connectors to IROSA, then both will move to either side of the legacy array to disconnect the old array and connect a Y cable. This will allow power to flow from both the new IROSA and the legacy array to the space station power system. At this point, EV-1 moves into a deployment viewing position, and EV-2 will release the final 2 bolts restraining IROSA in the undeployed position. IROSA will deploy over the next 6 to 10 minutes. During deployment, EV-1 translates back to the IROSA carrier to reconfigure the carrier beams that previously held the upper IROSA. These beams need to be rotated out of the way to allow access to the lower IROSA on the second EVA. Once deployment is complete, EV-2 will release 2 bolts that allow the IROSA blankets to become tensioned. EV-2 then cleans up the mod kit worksite, retrieving his crew lock bag, and heads to the carrier to help EV-1 with the carrier beams. The crew members will work together to release the bolts holding the beams in place. Then they will rotate the beams out of the way and secure them back down. This is the last task in the first EVA. Both crew will clean up the worksite and translate back to the airlock. They will clean up their tethers on the way. They will then work to ingress and begin repressing the airlock. This will finish the first of 2 EVAs.
And that was an overview of what we can expect during today's spacewalk. On your screen here on the top right, you see NASA astronaut Frank Rubio continuing to step through procedures to get the crew ready to head out of the airlock later this morning. And towards the lower left of your screen, you see United Arab Emirates astronaut Sultan Al Nayati. He's working alongside Rubio to prepare to get the simplified aid for EVA rescue or SAFER installed. Once the SAFERs are installed on both Hoburg and Bowen, the crew will move through the airlock and start depressurization procedures. Wow.
Copy, Frank. 0009. Getting a good view inside the backside of the Extravehicular Mobility Unit, or EMU. Those are the spacesuits that the crew will be wearing during today's spacewalk. They're essentially a mini life support system and provide all of the environment, protection, mobility, and communications for the crew members during the spacewalks.
As Rubio and Alnayati continue to step through those procedures ahead of getting the crew ready to begin depressurization, we do have some statistics to go through today for our spacewalk. Today's spacewalk will be the 9th spacewalk for NASA astronaut Steve Bowen. He has a total spacewalking time of 54 hours and 19 minutes, and for NASA astronaut Woody Hoberg, this will be his very first spacewalk. Today's spacewalk will be the 264th spacewalk in support of space station assembly, maintenance, and upgrades, and will be the 7th space station spacewalk this year. And this will be the 5th spacewalk for Expedition 69.
To station on 1 for step 11, time 1214.
And we copy, Frank.
And if you're just joining us this morning, we have 2 spacewalkers preparing to exit the International Space Station's Quest airlock to install a new ISS rollout solar array. Those spacewalkers are NASA astronaut Steve Bowen, who you see in the center of your screen there.
Station on 1 for step 18, extended canisters are 0022 and 0020.
Hey, copy, Frank. Good numbers.
And our other spacewalker today is NASA astronaut Woody Hoberg, who will be completing his very first spacewalk. Also in the equipment airlock is NASA astronaut Frank Rubio, as well as United Arab Emirates astronaut Sultan Al Nayati. They're continuing to step through procedures with the crew ahead of getting them into the crew airlock for the depressurization sequence. in the International Space Station Flight Control Room, the Orbit 2 team is ready to support today's spacewalk under the direction of Flight Director Diane Daly.
Station on 1 for step 21, time 12.
And copy, Frank.
In addition to Flight Director Diane Daly, the rest of the Orbit 2 team is supporting here from Mission Control Houston as well. To her right at the Capcom console is the ground IV, and that is Canadian Space Agency astronaut Jenny Gibbons. She'll serve as the spacewalk communicator who will talk directly with the crew during the spacewalk, helping them choreograph timelines and procedures. And to her right is NASA astronaut Nick Hague, who is the Capcom. You'll hear him communicating with the crew up until the point of depressurization this morning, at which point the ground IV will take over communicating with our spacewalking duo. Everything continuing to go smoothly this morning. The next major milestone that we can look ahead to is the installation of the Simplified Aid for EVA Rescue, or SAFERS, essentially the space jetpack. This is installed as a precautionary measure in the very unlikely event that a crew member were to become untethered from the International Space Station. This jetpack would allow them to get back to the space station. Following SAFER installation, we can look ahead to depressurization. First, the crew will move to the crew lock section of the Quest airlock, and depressurization will occur in a two-stage fashion. First, the crew lock will be taken down to 5 pounds per square inch of pressure. At this point, they'll pause depressurization to do a systems check, and then
Houston on 1.
And we are seeing Alneati and Rubio work together to install the safer.
Hey Frank, I've got one go back for you. Step 8, we Ojo go. Your go to turn off the HECA. It's just, if you want to turn off HECAs on both EVs, that'd be great.
Thanks so much.
Again, Alneati and Rubio now working together to install the safer, simplified aid for EVA rescue on NASA astronaut Steve Bowen's spacesuit. And Rubio and Alneati working to get that safer installed on NASA astronaut Steve Bowen's spacesuit. For today's spacewalk, Bowen is designated EV1, and he'll be wearing the spacesuit with the red stripes, which you can see on your screen there. Woody Hoberg will be designated EV2 and will be wearing an unmarked spacesuit. Once both SAFERs are installed, the next milestone that we can look ahead to is depressurization, and ultimately when the crew will then exit the International Space Station's Quest airlock. They'll then work together to install an upgraded International Space Station rollout solar array on the 1A power channel on the starboard truss of the International Space Station. The IROSs were delivered on a SpaceX Dragon cargo resupply craft on Monday to the space station. Rubio and Alnayati continuing to get the safer, simplified aid for EVA rescue installed on NASA astronaut Steve Bowen's spacesuit. Following installation of the safer, Bowen will be moved to the crew airlock for depress. And Bowen now being moved into the crew airlock. Next up, Rubio and Alnayati will work together to get Hoberg's safer installed. and Rubio and Al-Nayati now going to work together to get the SAFER installed on Hoberg's spacesuit. Again, he'll be designated EV2 and he's wearing the spacesuit with the unmarked spacesuit this morning. As Rubio and Al-Nayati continue to step through those procedures to get the SAFER installed, we can take a quick look ahead at what's to come. Following getting the SAFER installed, both crew will be moved into the airlock to begin the depressurization process. The depressurization of the airlock is done in a two-stage process. First, the crew lock will be taken down to 5 pounds per square inch of pressure. At this point, depressurization will be paused to do a systems check. Following this, depressurization will resume and continue all the way down to vacuum. Now, once vacuum is reached, the two spacewalkers will complete suit and communication checks before placing their spacesuit on internal battery power, which will officially mark the start of today's spacewalk. A U.S. spacewalk's start and end time is measured from the time the crew places their spacesuit on internal battery power all the way up until the time repressurization occurs, and they're back inside the crew lock following completion of their spacewalk. We are expecting today's spacewalk to last about 7 hours. And here in Mission Control Houston, NASA Flight Director Diane Daly did just pull the team of flight controllers on console, and everything is looking good. We are go for today's spacewalk. Rubio now going to work to get Bowen moved into the crew airlock. Hoberg, rather. Bowen currently is in the crew airlock already. Both Bowen and Hoberg now in the crew airlock. Once they get situated and everything looks good, we will see the hatch close and the depressurization process begin.
Station Houston, when able, on one.
Deck with you on one.
Hey Frank, we're trying to get in front of an LOS with some ground commanding. There's a couple steps that you're going to confirm later on we'd like to do early. That's step 76 and 77.
And that was the voice of
76 and 77 are in good config. Humor antennas closed and nose on map is connected to the gamma cat.
Copy, Frank. Thanks for doing this.
And that was the voice of today's Capcom and NASA astronaut Nick Hague, calling up to Rubio, letting him know that there is a loss of signal coming up, giving them the go to step through a couple of procedures during that LOS.
Station Houston on 1. No action for you. You can acknowledge with the thumbs up. We're going to command, so you go hot mic for the EV crew. And Station Houston, we're with you on 1. If you try to transmit last, I want to let you know the crew is going to go hot mic here shortly, and also you've got to go in step 84.
Okay, next copy. Crew will be hot mic and go on step 84. And then just be advised, you're coming in a little bit weak. You're readable.
Copy all. Station Houston, you are hot mic.
81 copy. 83 copy.
And copy, we've got good voice, and just let you know we're 2 minutes out for a 12-minute LOS, and you are prime IV, and your go to press.
And then I copy prime IV. Go to press. Thanks so much.
And we did just hear that confirmation from the ground that the crew is go to continue depressurization. First up, they'll close the hatch, which Alnayati and Rubio are working together to do, as you can see on your screen.
The flash is going to close. Goodbye. We'll gear it away. Yep, talk to you later. Thank you so much. Great job. Great job. Sound awesome.
And you did see that hatch just get closed. We are in an expected handover between ground stations, so we are not going to expect to have video of the crew on board the International Space Station for the next 11.5 minutes. However, we do know that they're going to continue the depressurization process as they have the go from the ground to do so. And if you're just joining us this morning, we have 2 spacewalkers who are suited up and in the process of working through depressurization procedures. Today they will exit the station's Quest airlock to install an upgraded IROSA, or International Space Station Rollout Solar Array, on the 1A power channel on the starboard truss of the International Space Station. We do have an animation to walk us through what we can expect our spacewalkers to complete today, so let's take a quick look.
This video is for the ISS Rollout Solar Array, or IROSA, 1A install EVA. Steve Bowen, EV1 with the red stripes, egresses and there. EV2 with white stripes, Woody Hoberg, egresses with the Krulak bag on his body restraint tether and closes the thermal cover. EV1 translates up the forward face of the truss and goes starboard. He stops to configure safety tethers. EV2 follows a similar translation path and goes to the port crew equipment translation aid card to temporarily stow his bag and retrieve an articulating portable foot restraint. Meanwhile, EV1 translates to the IROSA carrier, stows his bag, and retrieves his pistol grip tool. EV1 begins preparing IROSA for removal from the carrier, first releasing a restraint bolt on the upper IROSA. EV2 relocates the foot restraint and installs it on the space station's robotic arm. EV2 ingresses the foot restraint, and then the arm will move away from the truss. EV1 translates to the lower IROSA and releases its first restraint bolt. He releases both anti-rotation devices back on the upper IROSA, and then will stow them in the Krulak bag. On the robotic arm, EV2 is flown over to access two sets of bolts on the boom end of the upper IROSA. The first two bolts will allow the boom deployment system rollers to be moved into place to help with the array deployment later in the spacewalk. The second two bolts will release two of four mechanisms that hold the IROSA in its rolled-up configuration. EV1 partially releases the upper IROSA's restraint bolt and installs the first of two handling aids called scoops and prep for removing IROSA from the carrier. The arm flies EV2 over to the hinge end of the upper IROSA, and both crew members work to release the final bolt holding it to the carrier. EV1 installs a second scoop, and EV2 lifts the IROSA off of the carrier. After several maneuvers on the robotic arm, EV2 will arrive at the 1A mod kit worksite. During these maneuvers, EV1 will pick up the temporarily stowed bag from the port cart and reconfigure both crews' safety tethers, on his way to meet EV2 at the mod kit. Both crew will then work to install IROSA onto the 1A mounting bracket. The crew will release the scoops, and EV2 will move into position to release the final bolt, holding IROSA in its folded position. Once released, EV1 will hold IROSA closed while EV2 egresses his foot restraint and gets into position. Both crew will then work together to unfold IROSA and secure the right side onto the mounting bracket. Once secured, EV2 will drive two hinge bolts that hold IROSA in the unfolded position. EV2 will then move away from IROSA to reconfigure a safety tether on the arm. EV1 works to drive 8 bolts to fully secure the IROSA to the mounting bracket. Both crew will then work to electrically connect the new IROSA to the ISS power system. They'll first attach 4 connectors to IROSA, then both will move to either side of the legacy array to disconnect the old array and connect a Y cable. This will allow power to flow from both the new IROSA and the legacy array to the space station power system. At this point, EV1 moves into a deployment viewing position, and EV2 will release the final 2 bolts restraining IROSA in the undeployed position. IROSA will deploy over the next 6 to 10 minutes. During deployment, EV1 translates back to the IROSA carrier to reconfigure the carrier beams that previously held the upper IROSA. These beams need to be rotated out of the way to allow access to the lower IROSA on the second EVA. Once deployment is complete, EV2 will release 2 bolts that allow the IROSA blankets to become tensioned. EV2 then cleans up the mod kit worksite, retrieving his Krulak bag, and heads to the carrier to help EV1 with the carrier beams. The crew members will work together to release the bolts holding the beams in place. Then they will rotate the beams out of the way and secure them back down. This is the last task in the first EVA. Both crew will clean up the worksite and translate back to the airlock. They will clean up their tethers on the way. They will then work to ingress and begin repressing the airlock. This will finish the first of 2 EVAs.
And that is a high-level overview of what we can expect from today's spacewalk. If you're just joining us, 2 NASA astronauts are currently suited up and in the crew airlock and are working their way through depressurization procedures. Today's spacewalkers are NASA astronaut Steve Bowen, and today will be his 9th spacewalk, as well as NASA astronaut Woody Hoberg, who will be completing his first spacewalk. Bowen and Hoberg will venture outside for a spacewalk expected to last about 7 hours today, the focus of which will be on the starboard truss of the International Space Station to install and monitor the deployment of one of the IROSAs, or ISS Rollout Solar Array, both of which were delivered on a SpaceX Cargo Dragon resupply vehicle on Monday to the space station. And today's spacewalk is the 264th in support of space station assembly, maintenance, and upgrades. This is the 7th spacewalk in 2023 and the 5th spacewalk for Expedition 69. As we mentioned, it's the 9th spacewalk for Bowen, who has a cumulative spacewalking time of over 54 hours across 8 previous spacewalks. The IROSA that the crew will install today is 60 feet long and 20 feet wide. It shades a little more than half of the original or legacy arrays, which are 112 feet long by 39 feet wide. Each new IROSA produces more than 20 kilowatts of electricity, and once all the IROSAs are installed, it will enable a 30% increase in power production over the International Space Station's current arrays. And we are in a loss of signal period as we have a handover between satellites. However, we are expecting communications and video to be back here in less than a minute. During this loss of signal period, the crew has been stepping through procedures in order to work through depressurization of the airlock. This is done in a 2-stage process. First, the crew lock goes down to 5 pounds per square inch of pressure, at which point that depressurization will be paused to do a systems check. And then following this, depressurization will resume to bring it all the way down to the vacuum. Now, once that vacuum is reached, the 2 spacewalkers will complete some additional suit and comm checks before placing their spacesuit on internal battery power, officially marking the start of today's spacewalk. And pressure inside of the crew lock is about 7.27 pounds per square inch. Again, we'll pause once that pressure reaches 5 pounds per square inch.
And Station Houston on 1, we're back with you, voice only.
Yes, we have you on clear, copy, voice only, thanks. Hey, Stephen, what do you guys thought? You have about 100 millimeters of mercury to go?
You doing copy? Yep, Frank, I copy. That's the airlock P6.5.
Yes, I agree.
Pressure inside the crew lock now at 6.35 pounds per square inch of pressure. Now less than 6 pounds per square inch of pressure inside the crew lock. Again, once we do reach 5 pounds per square inch, that depressurization will be paused to do a systems check. Everything's still looking good for depressurization, now at 5.18 pounds per square inch of pressure inside the crew lock.
What is the next action going to be for you? We have about 10 to go.
I copy, Frank, standing by.
Woody, T-breath pump and ISO valve closed. Both of you can expect an alert tone.
Closed.
And copy closed. Okay, next thing we're going to do is a leak check. So you'll both take your switch display status until leak check question mark is displayed. Hold that for 2 seconds, and then follow the displayed instructions.
In order to do what? UV2 in work.
And pressure inside the crew lock is now at 5 pounds per square inch of pressure. So you did hear those words about the systems check that are occurring now. Following the systems check, depressurization will resume and continue all the way down to vacuum. And once vacuum is reached, the two spacewalkers will complete some additional suit and communication checks before they place their spacesuit on internal battery power, officially marking the start of today's spacewalk. And following this, the crew will, of course, exit the airlock and begin working to get that IROSA installed.
Check complete, EV1. Moving to EVA. That'll be a minute. Same for EV2.
Copy, good. Recheck for both. Good news. And then correct. Both want your proposed launch range with EVA. Let me know when that's complete.
EV2 then EVA. EV1 then EVA.
The O2 actuator, EVA from both Woody and Steve. Nice job. Woody, you're going to take the defense pump man ISO valve to open. Both of you can expect an alert tone.
Copy. Press pump man ISO valve is open.
Okay, emergency MPAV is also open. Both of you continue to monitor your suit pressure gauge. Make sure that it remains less than 5.5. Again, if it ever goes above 5.5, let us know and we'll stop the depress.
If you want to come, EV2 come.
Woody, the next action will be at 2 PSI.
Copy, I see it.
And those system checks looking good. Depressurization is continuing as expected. Pressure inside the crew lock now less than 4 pounds per square inch of pressure. Pressure inside the crew lock now approaching 3 pounds per square inch of pressure. And we are getting a view back inside of the equipment lock here, where NASA astronaut Frank Rubio on the left and United Arab Emirates astronaut Sultan Al Nayati continue to step through depressurization procedures with Hoberg and Bowen, who are inside the crew lock. Pressure inside the crew lock now at 2.68 pounds per square inch of pressure. Once vacuum is reached inside the crew lock, the two spacewalkers will complete additional suit and communication checks before they do place their spacesuit on internal battery power, which will mark the official start of today's spacewalk. A U.S. spacewalk start and end time is measured from the time the crew places their spacesuit on internal battery power.
And we're at 133, continue continuing to 103.
Copy, Frank, thanks. Receive 2.1.
Now closing in on 2 pounds per square inch of pressure inside the International Space Station's crew lock.
Okay, Woody, we're at 103. Depress pump and ISO valve closed. Closed. Copy, closed. Woody on the UIA, switch depress pump power off, OFF.
Depress pump power is off.
Okay guys, I will turn you over to Jenny for your initial tether config. And Jenny, you are prime.
Copy, I'm prime. Ready for the config.
Sounds great. Jenny, I'm in a great position to read you the config setting of the airlock gearing extender.
Go.
Alright. Airlock gearing extender, I have my left waist tether, gate closed, locked, block unlocked. The waist tether small hook is on my left gearing extender. Gate closed, locked, block unlocked. Also on my left gearing extender, I have my red hook. Gate closed, locked, block unlocked. The red reel and green reels are both unlocked. The red reel's yellow hook is gate closed, lock, block, unlocked to my green reel. My green reel's small gate hook is gate closed, locked on my red reel. And the green reel's anchor hook goes to Steve's right waist tether. Okay, so and that anchor hook and Steve's waist tether large hook are both gate closed, locked, block, unlocked. Steve, over to you if you can see it. Yep. So, we pick up with my waist tether, which is gate closed, slide lock, take hook that you... Take together, red hook, gate closed, slide lock on my right D-wing, extender. Yellow hook is gate closed, slide lock to the green rail. Both reels are unlocked. I have the blank hook to my mini workstation. On my left hand side, I have Alright, what do you guys? Let's go.
Copy all. That is...
back so I can actually eventually open the hatch.
I copy all. We are in a good config.
Thanks so much, Jams, and good morning to you and the Orbit 2 team.
Good morning. We are happy to be here. Excited to work with all of you.
And you are now hearing the voice of Jenny Gibbons, who is the ground IV. She'll be stepping through procedures with the crew during today's spacewalk. And that pressure inside the crew lock now at vacuum.
Woody and Steve, we're continuing the deep press here. It'll take a couple of more minutes. When the crew lock DPDT is approximately 0, expect an alert tone.
D1 copies. BB2 copies.
That pressure inside the crew lock is continuing to approach vacuum. It's now at 0.97 pounds per square inch.
You guys, caution, good luck out there. It's going to be fun to watch you guys do this.
Frank, we're depending on you. This is going to be good. You guys are going to work with us. It's going to work out really well. Frank, thanks so much. You guys did a fantastic job IVing this morning. Thanks so much for everything.
Our pleasure. We'll see you in a few hours.
Everything continuing to go smoothly this morning as NASA astronaut Woody Hoberg and Steve Bowen.
Around 8 or 9 more minutes down to 0.5 psi.
And JA, that makes sense. Watching it go very slowly.
Sounds good.
Again, everything going smoothly so far this morning as we anticipate the spacesuits to be switched over to battery power here shortly as soon as those comm checks and system checks are completed. Following this, the crew will egress or exit the hatch after they open the thermal cover. And we are continuing to get views inside the International Space Station. You are seeing NASA astronaut Frank Rubio, who helped to get Bowen and Hoberg suited up and ready to go this morning. All Nayati now floating into screen as well. Bowen and Hoberg are inside the crew lock, which continues to depress, now at 0.64 pounds per square inch, rapidly approaching vacuum. The goal of today's spacewalk is to install an upgraded IROSA, or International Space Station Rollout Solar Array, on the 1A power channel on the starboard truss of the space station. Today's IROSA installation will be the 5th installed on the space station. Pressure inside the crew lock now at 0.55 pounds per square inch of pressure. And pressure inside the crew lock now at 0.5 pounds per square inch of pressure.
Stephen Woody, we are at 0.5 psi. You are go to verify the EV hatch gauge is less than 0.6 psi and open the EV hatch.
And I see the EV hatch at 0.4.
Copy 0.4, you're go.
All right, get ready to open the hatch. Valve is coming close.
Copy, Steve.
Equalization valve is closed. Hatch is open, equalization valve is closed.
And we are hearing that the hatch is open. Pressure inside the crew lock now at vacuum. Both Hoberg and Bowen are now going to work together to egress or exit the airlock.
Copy, Frank. Emergency MPEV closed. Now we are in post-depress. Woody and Steve on your DCMs. Switch power to BAT. Stagger your switch throws and expect a warning tone.
EV1 power. Over to battery. Copy. EV2, going to battery. EV1, good restart, blank, no bite. EV2, good restart, blank, no bite.
Copy. We verified you have a functional display. Switch power EV1 and 2 to off OFF on the UIA.
Alright, UIA. Power EV1 and 2. Both on.
Copy. Check power EV1 and 2 LEDs. All 4 are off OFF.
4 LEDs off.
Copy, off. Switch display to Pro to verify functional display.
EV1 switch display functional. EV2 display functional.
Copy, 2 functional displays. You can disconnect your SCUs, install your DCM covers, and stow the SCUs in their pouches.
EV1 in work. EV2 in work. Alright, EV1 has correction EV2 has you in the pouch.
Advise, what's the fingers in the pouch?
Copy EV1 and EV2 as the user in the pouches. On the check, depress pump, manage 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 pump.
Advise. Alright, EV1, lead marathon.
Copy EV1.
EV2, TCD marathon.
Copy EV2. Switch water on.
EV1, water on. EV2, water on.
Check DCM blank light off.
And at 8:25 a.m. Central Time this morning, the 264th spacewalk in support of station assembly maintenance and upgrades has begun.
PCVs as desired. Report all subsequent changes to MCC.
EV1 set to 4. And EV2 also at 4.
Copy both TCVs set to 4. Report suit pressure gauge.
EV1 4.2. EV2 4.4.
Copy 4.2 and 4.4. Set your visors as required. We have around 10 minutes till sunrise.
1 copy. 2 copies.
All right, with that, Steve, you can open the thermal cover. We'll have you stow the hook on the stiffener tether point, cinch the strap, and report Sharpie lines visible.
Alright, I get my tethers back to where they belong. They were bouncing around a bit.
And we are expecting the thermal hatch cover to open momentarily.
The hook is released. Connected and off.
And we are seeing that thermal cover begin to open.
Is preparing to egress. You can retrieve crew lock bag M. You'll be throwing this on your BRT and handing crew lock bag T out to Steve.
Alright, Johnny, sounds great. Alright, I got 1, 2, 3, 4, 5, 6 lines visible.
Copy, Steve. That's a good config. Egress the airlock.
Alright, that's fine.
And we are seeing NASA astronaut Steve Bowen egress the airlock. He's designated EV1 today, and he'll be wearing that spacesuit with the red stripe, so he's the first out of the airlock.
My bearings here. Steve, no rush at all. I've got crew lock back to you when you're ready. Okay. Just give me a second.
Bowen is still inside the airlock. He'll egress here shortly, but first he's going to hand a crew lock bag to Steve.
Okay, let me get my PRT ready. Sounds good. Steve, you have the bag. I am back. Is stowed on my PRT. And locked.
Houston, copy.
Great, Steve, awaiting your go to egress. Alright. Trying to get my others clear. Alright, you have a go to egress. Copy, go to egress, thanks.
After egress, you can both turn on your HECAs and perform buddy checks.
Copy, Johnny, thanks.
And next out of the airlock is going to be NASA astronaut Woody Hoberg, who is completing his very first spacewalk this morning. He'll be wearing the spacesuit with no stripes on it, the unmarked spacesuit, and his designation is EV2. Once both crew members are out of the airlock, they'll work to translate to their next location, but first they're going to turn the lights on their helmet cameras.
That's what sounds like the CR6 radio. There you go.
Both crew members now out of the airlock.
I'm gonna plan to be aft, Steve. Alright, come back around the other way then. Sounds great. But I'm in a great spot for buddy checks if you want to do them here. Yeah, we'll just do them here. Okay, great. Take it away.
Houston's ready to copy buddy checks. Confirm your HECAs are on.
And I see. What are you saying this way? I see. Green light. Where's the other one? Your EMTV is off. Is it? Okay. Goodbye. You set the handles down. And one tap up. Just get my crew lock bag on. Yep. And just Alright, Steve. Ready when you are. Alright, let me see. One thing left to check. Oh, your light's pretty bright. Your EMTV still not on yet. Hey, Jay, hit the button. Oh, there it is. I see it now. Okay. Okay. And, I see full safer handles down. I see 2 tabs up. And I see 2 green lights. And I see your lights are off. Alright, Steve, for you, I see 2 mini workstation tabs and a BRT tab, all 3 up. I see a green WVS light and a green HECA light. Your lights are on. You got tools and tethers. Put your bag on the BRT. And you're looking good, Steve. Alright. Alright, and let me check your super handles. 1, 2, both down. Looking good. I'm starting off. My gloves look good, and I have a dry hat. And my gloves secured, and I have a dry hat as well.
Houston copies. Good buddy checks. Good glove checks and dry hats for both of you. You can tend the thermal cover closed, and Steve, you'll be translating to the anchor hook location. I have more words for you when you're on your way.
All right, give me 1 second. Get the cover closed, and then I'll be on my way. I got the cover, Steve. All right. Yeah. And Jenny, I'll have to hold on fully closing the cover for my waist tether.
Copy. Just tend to close for now. Thanks, Woody.
Copy.
And Bowen and Hoberg completed some initial checks to ensure everything is looking good on their suits. They're now going to get that thermal hatch cover closed.
Steve, I have a caution for you. Avoid contact with the deployed test cable.
Okay. Understand. Avoid contact with the test cable.
Good readback for you both for around 2 minutes to sunrise.
What's my mile marker, by the way?
You're looking for the FHRC. So F1 FHRC.
Okay. On my way.
And Hoberg is getting the thermal cover closed. Meanwhile, Bowen is translating up the forward face of the truss.
Steve, that mile marker is 6300.
6300. Thank you.
Once the thermal cover is closed, Hoberg is going to follow a similar translation path, but he's going to stop at the port crew equipment translation aid cart, and he's going to pick up an articulating portable foot restraint. This is going to be required for him later in the spacewalk when he steps into it on the Canadarm2.
This is where you'll place your anchor hook. It's the nadirmost handrail under the FHRC. We're looking for the nadir stanchion.
All right, nadir stanchion. My blank hook, gate close slide locked. Do the green reel, which is unlocked. The yellow hook is locked, gate close slide locked. Red reel is unlocked. Cumulative right steering extender. Just gate close slide locked. And the green hook between the green and red jet wheels is gate close slide locked.
Copy. That's a good config, Steve. We need Woody's anchor hook on handrail 3247, which is the zenith handrail, just above yours.
Okay, that didn't work. And Woody's hook. We close flyer locked. If he's pinning back to the airlock.
Copy. That is a good load path for Woody. You can give Woody the go to release his waist tether.
And would you have a go to release your waist tether? Steve, I copy, picking it up.
Steve, you can now translate to the FSE worksite. You'll be dropping your green hook on S3, handrail 3011, which is nadir of the port seat cart.
3011. Out there now.
Copy. Steve, or Woody, excuse me. Once that's complete, you can close the thermal cover.
I You broke up your gyms, but close thermal cover.
Copy. Woody, once that's complete, you can translate. You are headed to the crew lock bag stowage location on the port Cedar cart.
All right, Jenny, I copy. Thanks.
Steve, when ready, I have cautions and a warning for you.
Okay, stand by. All right, ready to listen.
Warning, grapple shafts and curvet coupling are no touch. And cautions, no aggressive movements or quick grabs on the FSE. Translate slowly. Wait for motion to dampen out before imparting loads, and do not contact the IROSA blankets.
All right, I understand and copy all.
And with the thermal cover closed, Hoberg is now working to translate to the flight support equipment work site. This is essentially a pallet that is currently holding the IROSAs.
Green wheel is coming for 3011. Green hook, I should say.
I copy your green hook on handrail 3011.
3011 or 3011?
3011.
Okay.
Following this, Steve, you'll be translating onto the FSE via the POA.
And the crew is running about 10 minutes ahead of today's timeline. Today's spacewalk is unique in that once the International Space Station rollout array, or IROSA, is installed, cables will need to be mated during an eclipse portion, so this spacewalk is very carefully choreographed to ensure that this timing takes place as necessary. And you are seeing this view from the helmet cam of NASA astronaut Woody Hoberg, who is completing his first spacewalk today. He's continuing to translate or make his way over to the pallet where the IROSAs are installed.
On port Cedar cart, mater handrail.
Copy, Jim.
He's currently at the port CETA cart where he's going to temporarily drop off one of his crew lock bags. And he's also going to pick up an APFR, an articulating portable foot restraint, which will allow him to step into and ride on the Canadarm2. Hoberg will be carrying the IROSA while he's on the Canadarm2 in order to move it over to be installed. Today's solar array will be installed on the 1A power channel on the starboard truss of the International Space Station.
Seconds to a short handover.
And we are in a brief expected handover between satellites, but we'll regain communications and video with the crew during their spacewalk here momentarily.
Steve, Woody, I'm back with you after the handover.
Copy. Can I see that small bushing on the OR Rosa? Passing it?
Copy, you have eyes on the FOD. Thanks, Steve. Woody, you will be picking up the APFR in West 3. Looks like you're already there. Should have an ingress aid.
And it does.
And this view from NASA astronaut Woody Hoberg's helmet camera as he works to pick up the articulating portable foot restraint from the port CETA cart.
Danny, just reporting the locking paddles on this APFR is very sticky.
Copy. Sticky locking collar, Woody.
Working on it. The paddles.
Copy the paddles. Woody, this is in line with what we expect for this APFR.
Okay, copy. D2 TCVs.
Copy, a TCV of 2 for Woody.
-7.
Copy, 7.
All right, just confirming that the adjustable large small goes to 0008, and the integral goes to the upper handrail.
Affirm, that's right. Steve, that handrail should be 13. Once that's done, I'll take a glove inspection, half check.
Enter this in place.
And while Hoberg works to secure that articulating portable foot restraint after grabbing it from the port CETA cart, we are going to hear Bowen complete a glove and HAP check.
You're headed to the inboard ingress location.
The HAP is the helmet absorption pad, and this is checked regularly throughout the spacewalk along with the gloves just to ensure that everything is performing as expected. With the articulating portable foot restraint now in hand, Hoberg is going to work to install it on the Canadarm2.
Alright, I've got the integral on 0013 and the large small adjustable on 008.
Copy.
Just back up a little bit.
Woody, I have your next step, working with Frank to GCA to the published APFR install position.
Alright, James, I agree. Steve, do you need the comp? Just for 1 second, I'm going to head over to R5 on the upper. And I see it. And what am I setting there, Jenny, if I'm going to lose talk?
And Steve, can you confirm that you've picked up the PGT? I left the RET on the bag, so that's now on your swing arm, and I need a glove inspection half check.
Okay, need the glove inspection half check first.
And we were getting a view there briefly of the IROSAs. There we see it again here, the International Space Station rollout arrays. There's 2 on that pallet on the very left of your screen. One of them is going to be installed today, and the other will be installed on June 15th. We're also getting a view of the Canadarm2, which Hoberg will be utilizing today when he moves the IROSA to the 1A power channel.
Give 1 second. Alright, Jenny, I have the PGT, and you want me to leave this RET on here, correct?
Affirm, leave the RET on your swing, or leave the RET on the bag and RET swap to the swing arm RET.
Alright, that's gonna work. Give me the PGT settings and give the column 2, please.
Bravo 2, counter 2.
Bravo 2, counter 2. Alright, I'll let you know if we get contact before it's done, if I haven't done it yet.
Copy, and that was a good readback.
I am Jared Woody, you heard out the call. Copy, thanks.
And also in your frame there you can see a Dragon vehicle that actually brought up the ISS rollout solar arrays. That Dragon docked to the International Space Station on Monday.
Bringing the arm towards you, that is station.
Following the docking, the ISS rollout solar arrays were removed from Dragon's trunk and placed on that pallet that you just saw there. And next, our spacewalkers are going to work to remove that first IROSA solar array by removing some bolts and working through some procedures to loosen it up before it can be hand carried by Hoberg on the robotic arm.
Half a meter to go.
Continue.
Copy, continue. To go.
Continue to publish.
10 to go, continuing to publish. And ramping out. Okay, with you, that is our published position. How's that looking?
Alright, Photon, can you please give me 50 centimeters station meter?
Copy with the half a meter station meter in work.
Thank you. I see good motion.
Copy, good motion. Okay, 30 centimeters to go.
Continue.
Continuing. Okay, ramping out. Okay, with you, that is half a meter station meter.
Copy, Photon, that is GCA complete, that's the perfect position.
Right, copy, GCA complete, and brakes are coming on.
Copy, brakes on. And I'll be installing the ADSR.
Woody, we're looking
That's
for...
affirmative, you are going to install the ADSR.
Woody, we're looking for a clocking of 12.
Copy, clocking 12, and I already confirmed Papa, Fox 6, set.
Good settings. Steve, I'm back with you.
Extra. We got 5 turns, 502 counterclockwise 2, and releasing R5.
Copy. The boat will spring out when fully released, and you'll see a white line indicator. Expect 18 to 20 turns.
Hoberg continuing to step through procedures to get that articulating portable foot restraint installed on the Canadarm2. This articulating portable foot restraint, or APFR, allows him to click his spacewalking boots into it so that he can ride aboard the Canadarm2. He'll be carrying the IROSA while he does so.
Any APFRs installed in the arm. Talking at 12, Papa Fox 6. Always lock on glide, good pull twist test, and the pitch knob can be depressed.
Copy, Woody. Good checks. Now we'll need you to perform a safety tether swap to the arm. Let me know when your yellow hook is on the SSRMS tether point, and I'll take your checks.
Alright, sounds good, Jimmy. Alright, that bolt is released. I got 27 turns. They let us do a couple of bumps. So that we verified it was clear.
Copy. 27 turns and the bolt is fully released. Can you see a white line indicator?
And there's a white line indicator.
Copy. You can stow your PTT.
And we are currently in an expected handover between our satellites. We do have communications with the crew, however, we do not have video at this moment, but we'll regain it.
Copy. Translate to Stanchion Bravo.
Hoberg has completed installing the APFR on the robotic arm.
Hey Jenny, my yellow hook is gate closed, locked, block unblocked to the SSRMS. Tether point, green hook is stowed on mile marker 6360, and that green reel is unlocked.
Copy, Woody. That is a good config. Ensure that Steve's tether is clear of your green hook, and then you can work with Frank to get to the ingress position.
Alright, let me get eyes on Steve's tether. It's well clear. And I am in a great config for APFR ingress. OGCA needed.
Okay, Woody, we are copy and brakes are still on. You are go for APFR ingress.
Copy, brakes on, go for ingress. Thank you, Sultan.
Woody, you need to attach a waist tether to the ingress aid.
Yep, in work, Jams. Thanks.
And Steve, say again if I missed a call from you.
I'm at Sector Bravo.
And Hoberg has successfully gotten that articulating portable foot restraint installed on the Canadarm2. He's now going to work to click his boots into the articulating portable foot restraint and ingress it. This will allow him to fly on the Canadarm2. And you are seeing him work to ingress that APFR on your screen right there.
Bravo 2, counterclockwise 2, going to R5, and looking for full release and a white indicator.
Good word, Steve. Expect 18 to 20 turns I have written here.
All right, 18 to 20 turns. Okay. And Steve, I'm going to look for the con again when you have a chance. Hey, good to go. Thanks. It's Sultan, I'm ready for thrust back off.
Right, copy. Woody, you are ready and brakes are coming off.
Copy, brakes off.
Woody, check your tools and tethers are clear. We need you to confirm that.
Thanks, James. Yep, tools and tethers are all clear.
Copy. I agree. You are a go to proceed. Woody, we also are hearing that your left safer handle might be up. We need you to check both of them.
Got it. Your team was correct. And both safer handles are down.
Copy. Both safer handles down on Woody. Thank you. You guys are doing great on time.
And Woody, when you are, we're going to bring you first station forward about 80 centimeters, and then station later 3 meters and 60 centimeters.
Con, I'm ready for all of that to go.
Then starting motion, station forward.
Good motion, Sultan.
Copy, good motion.
And as you can see on your screen now, Hoburg now being moved while in that articulating portable foot restraint on the Canada arm. That Canada arm is being operated by United Arab Emirates astronaut Sultan Al Nayati, who is inside the International Space Station. Hoburg is going to be translated to a better position to help NASA astronaut Steve Bowen remove some bolts and an anti-rotation device which will enable the iROSA to be released from the pallet. Following this, Hoburg will hand carry it while on the Canadarm2 over to the 1A work site.
Okay, 2 meters to go.
Continue.
Continue. Okay, 1 meter to go.
And this view from NASA astronaut Woody Hoburg's helmet cam as he is on the Canadarm2 looks like he's taking this opportunity to get some truly out-of-this-world photography.
And ramping out.
That looks good, Sultan.
Okay, Woody, just a heads up. Next, we're going to take you to the Volt Axis joint OCAS, and that'll be 2 minutes and a half.
I'm ready for that. Okay, thanks, Sultan. Okay, Jenny, I've got Bravo 3, counterclockwise 2 set up. There were 20 turns. The lower iROSA with a good white band.
Copy, I release. I understand R5 on the lower iROSA is released with 20 turns. You should be pretty much at the bolts for C2. We are going to work on releasing these anti-rotation devices so you can attach an adjustable equipment tether and from your small trash bag to the ARD tether point.
Okay, let me get that done.
You are ready when you are for the journal cast.
I'm ready for conference.
Then start the motion.
Copy. Good motion, Sultan.
Good motion.
And Hoburg continuing to be moved on the Canadarm2. Meanwhile, Bowen is working with the pistol grip tool, or PGT, to release bolts. This is a restraint bolt. Next up, he's going to work on releasing the anti-rotation devices. All of this is in preparation for ultimately removing the International Space Station rollout solar array from this carrier, this pallet that it is temporarily stowed on. And as Hoburg continues to make his way over to his first work site, the International Space Station is currently flying 258 statute miles off the coast of Nova Scotia over the North Atlantic Ocean.
Woody, we need you to repower your HECA.
Copy. Power off and power back on. We got it. Actually, Jenny, I just pressed the power button and I see a green light, so it should be on now.
Yes, we just needed you to power it on. That's correct. It was knocked off earlier.
Okay, copy.
Getting a really great view here of Woody Hoburg in the articulating portable foot restraint.
Counterclockwise to
Good read back.
the 10 turns, correct?
Yes, 10 turns only. A reminder, these are not captive, so we only want to release 10 turns.
10 turns only.
And in Hoburg's hand, you can see the PGT, or pistol grip tool. This is essentially the space drill. It's going to be utilized a lot throughout today's spacewalk, first to remove the IROSA from the pallet and then to reinstall it on the 1A power channel.
Copy, thanks, James. Good reminder, I have Alpha 4 counter 2 set for R1 and R2.
Those are good settings, Woody. It doesn't matter to us which of these bolts you do first, but the bolt will spring out when it's fully released. You have the same settings for both of them.
Copy, thanks. All right, I get 8.8 turns.
Copy, that was 8 turns. Steve, and you can remove the ARD, and then we'll be torquing back this bolt.
All right, pulling the ARD off. Like I said, Sultan, I'm ready for ML3.
Okay, Woody, we're need a few seconds to set up our values here.
Take your time. And the ARD is removed.
Copy, ARD removed. Your settings are Bravo 1 clockwise 2, and you'll be driving this stop block bolt to torque.
Bravo 1 clockwise 2. That's set.
Good settings.
Bravo. One clockwise.
Woody, ready for the next motion? So it's going to be body and meter and 60 centimeters.
That sounds great. You go for that motion.
Copy. Go and start the motion.
We are 48 minutes into today's spacewalk, and NASA astronauts Steve Bowen and Woody Hoburg are continuing to work together to remove bolts from the International Space Station rollout solar array in order to release it so that it can be carried on the Canadarm2. To step through the next set of procedures is I'm going to hand it over to my colleague, Anna Schneider, who's going to step through the next set of procedures with you.
That's over. Yeah.
Okay, 1 meter to go, Woody.
Continue.
Yeah.
All right, Steve, I copy 11 foot-pounds and a green light. Could you say turn count again?
Turn count was 25.
Half a meter to go.
Continue.
Copy, continue.
We're just checking on those turns, Steve.
It's bumper rolled on top of the mount. You may not get as many turns as you might have expected. Okay, so it's on stop motion. But you can look at it. It's on there nice and snug.
We are in the public position and you are go for unbolting.
Keywords on there. Copy. It's not turning. It's on the bump. It's on the mount. It didn't go past the mount. See it?
Now you can see NASA astronaut Woody Hoburg beginning to release the R bolts.
All right, Steve, I'm sorry, one more time. We're going to have you say what you saw on those turns and whether you counted the turns or you're reading them off.
Well, I counted the turns correctly. Bumper, the lock, when it turned, it went onto the mount where the bolt stands. Therefore, it is locked in place. You can still see treads below the bumper, and the C2 bolt is clear.
All right, thanks for the clarification again, Steve. This is a good bolt. You can store your PGT, and we'll have you translate to Stanchion Charlie for the Charlie 1 ARD.
Okay, hello, Charlie 4.
The bolts that Hoburg is working on are on the boom end of the upper IROSA, or International Space Station Rollout Solar Array. The first two bolts will allow the boom deployment system rollers to be moved into place to help with the array deployment later in the spacewalk.
Rotating the deployment system.
Bolt sprung out, and it was 9.5 on R2.
Copy 9.5. That is a good bolt release, Woody. We need you to access R3 and R4 next. You can GCA if you need to. I have new settings for you, and as a reminder, these will be the 245 turn bolts, so we need you in a good body position.
You just heard confirmation that Woody Hoburg successfully released 2 of the bolts, and he's moving on to the second set.
And Woody, we are ready.
Okay, so it's on half a meter station, correction, half a meter body down.
And we copy half a meter body down. Okay, starting motion.
Copy. Good motion.
Copy, good motion.
You're hearing some conversation between NASA astronaut Woody Hoburg and UAE astronaut Sultan Al-Niyadi, who is inside the space station operating the robotic arm, as he moves Woody Hoburg down a little bit to access the next set of bolts.
Okay, you can ramp out.
Stopping out. Motion stop.
GCA complete.
Copy, GCA complete.
Steve, once in position, you can tether to the ARD tether point, and then I have settings for you for the stop block bolt.
Complete. And I'm ready for settings.
Bravo 3, counter 2, 10 turns only.
Bravo 3, counter 2. And Jenny, I have Alpha 3, clockwise 3 for R3.
Copy Alpha 3 for clockwise 3. Verify your PGT turn count is 0.
Confirm it's 0.
Copy, PGT turn count is 0. You can release R3.
Copy. Starting turn.
Copy, Woody.
The second set of bolts that Woody Hoberg is currently working on will release 2 of 4 mechanisms that hold the ISS rollout solar array in its rolled up configuration. When folded, the IROSA measures approximately 10 feet by 2 feet by 4 feet.
Got 8 turns, and it's loose over the ARD.
Copy, 8 turns on the ARD, or on the stop block bolt, you can remove the ARD.
Left removed, the ARD's removed, ready for settings to drive back in.
Bravo 1, clockwise 2.
Bravo 1, clockwise.
30 seconds from short handover.
While NASA astronaut Woody Hoberg continues to work on those bolts, NASA astronaut Steve Bowen continues to work on the anti-rotation device.
Copy, Steve. You've driven the stop block bolt, 12.1 torque, 7 turns, and a green light. Steve, I'm back with you after the handover, 12.1 torque, 7 turns, and a green light. You can stow the ARDs in the crew lock bag.
Heading over there.
NASA astronaut Steve Bowen has released both of the ARDs, or anti-rotation devices, and will begin stowing them in his crew lock bag. Here on the screen, we continue to see NASA astronaut Woody Hoberg work on releasing the second set of bolts on the boom end of the upper IROSA.
Alright, the ARD's going in. And I think I pull out the, cool, the copy, Caddy.
Affirm, Steve. Those are good words. We need the 5/8 12-inch wobble on your PGT, and you can stow the 7/16 on the socket caddy.
All right. Then I'll put that in work. JOD is nice and stuff in here.
Copy.
Jenny, 245 turns, R3, turkey timer popped out.
Copy. 245 turns on R3 with the turkey timer popped out. Your settings are alpha 3, counter 3 for R4.
Alpha 3, counter 3, sag 0, turns on the PGT.
Here we go.
Sorry.
NASA astronaut Woody Hoberg is currently working on the last of the 4 bolts. These last 2 bolts release 2 of 4 mechanisms that hold the IROSA or ISS rollout solar array in its rolled up configuration.
The 12-inch wobble is good. Full test on the center caddy, going from the 5/8 12-inch.
Steve, I copy a good pull test on the 7/16 12-inch on the socket caddy.
That's correct. All right, good pull test on the 12-inch 5/8 wobble on my PGT.
All right, and good pull test on the 5/8-inch 12-inch on your PGT. Steve, now we will be breaking torque on the IROSA FSE bolt. You can translate to bolt Charlie 1, which is stanchion Charlie. Should be right next to you.
Charlie 1 right next to me. All right, there's Charlie 1.
We'll be breaking torque on this bolt, less than half a turn. Your settings are Bravo 3, counter 2.
Bravo 3, counter 2.
Good work.
And now I can make myself in a good position. All right, Bravo 3, counterclockwise 2.
Good words.
Less than half a turn, correct?
Affirm. And big picture for all crew, we are about a minute and a half from an LOS. We have voice comm for the first 5 minutes, and for the last 5 minutes, I'm still prime IV. I will hand over to Frank when I need to.
And Benny, you want copies that I had 0.5 more turns C1.
Copy. Torque broken on C1. You can translate to C2.
Okay, I copied R4 release 245 turns, turkey timer out.
Copy, Woody. Great job. R4 release, 245 turns, and you see the turkey timer. You can work with Frank to move to the carrier back off.
You just heard confirmation that NASA astronaut Woody Hoburg finished releasing the fourth bolt. That bolt was holding the IROSA in its rolled up configuration.
Woody, and this is basically putting you body out 1 meter 60 centimeters, and that is station forward.
You also heard them reference something called a turkey timer. That is basically just a status indicator to ensure that the bolts are fully released. We are now in an expected handover that will last about 15 minutes. We are currently about 1 hour and 5 minutes into today's spacewalk. It began at 8:25 Central Time this morning, 9:25 a.m. Eastern Time, when the spacesuit switched to battery power. Steve Bowen, who is EV1 with the red stripes, egressed the crew lock and received a crew lock bag, and then EV2, who is Woody Hoburg, followed him shortly after. Bowen then translated up the forward face of the truss and went starboard, configuring his safety tethers on the way, and then Hoburg followed a similar path, but went to the port crew equipment translation aid, or CETA cart, to temporarily stow his bag and retrieve the articulating portable foot restraint. Bowen then translated to the IROSA, or International Space Station Rollout Solar Array carrier, stowed his bag, and retrieved the pistol grip tool. Bowen began preparing the IROSA for removal from the carrier, first releasing a restraint bolt on the upper IROSA. Meanwhile, Woody Hoburg relocated the foot restraint and installed it on the space station's robotic arm. From there, Woody Hoburg ingressed the foot restraint, and then the arm moved him away from the truss and towards the work site. Bowen translated to the lower IROSA and released its first restraint bolt, and then released both anti-rotation devices on the upper IROSA and stowed them in the crew lock bag. While on the robotic arm, Woody Hoburg was flown over to access two different sets of bolts on the boom end of the upper IROSA. The first two bolts allowed the boom deployment system rollers to be moved into place to help with the array deployment later in the spacewalk, and then the second two bolts released two of four mechanisms that hold the IROSA in its rolled up configuration. The goal of today's spacewalk is to install an IROSA, or International Space Station Rollout Solar Array, to augment power generation for the 1A power channel on the space station's starboard truss. The new solar arrays measure 60 feet long by 20 feet wide once they're deployed, and shade a little more than half of the original solar arrays, which are 112 feet long by 39 feet wide. Each new IROSA produces more than 20 kilowatts of electricity, and once installed will enable a 30% increase in power production over the station's current arrays.